Yo, what's going on, everyone? We'll get started soon enough. I'll wait for people to filter in. What's up, Tricky? How you doing? Bro, you do know you don't only have us followers, right? Go live earlier, please. I don't know if I can go live earlier. I just kind of stream whenever I get the chance or whenever I can. So I don't really have a schedule or anything. I mean, a lot of times I've been streaming 3.5 hours from now, so this is earlier for us. Oh, US. Okay, I got you. US followers. Go earlier. Go live earlier, please. I really can't. I mean, I have a day job and then I have stuff to do. So right now it's like 8:30 p.m. my time. So like this is just the time where I can stream. So it's either this or nothing. So that's just what happens. But if you do want to catch up on the VODs, if you're missing it, all the VODs will be on YouTube because I'm dual streaming there. Let's see. What's up? 0 Day Zeus. How you doing? Good sir, when shall the Bash course see the light of day? If you follow my Instagram, I just posted a story. It's a picture of me uploading the final video to YouTube. Now, there were some mistakes with the final video, so I have to go re-encode it. I'm going to re-transcode the video tonight. I'm going to upload it to YouTube tonight, and it will go live officially it'll go live sometime in 2025. Unofficially, if you're watching my stream right now, I'm aiming for next week. So probably like next week, Wednesday or something. I'll make announcements about it, but within the next 7 days, the course should be up and ready to go and free, and it will be a long video on YouTube. So yeah, that's awesome. Cool. It's 2:30 here. Good luck with stream today. Gotta sleep. Yo, appreciate it. Thank you. And yeah, sorry. Like, don't get me wrong. I hope what I said didn't come across like rude or anything. I do wish I could stream and be more accessible to more people. If I could ever turn this into a day job, like if I could ever make content creation my job, absolutely, I'd be streaming earlier. Also, I'm realizing I'm wearing a gag t-shirt I bought as a joke that says Hog Exterminator. It's for a joke, but my laundry is so behind that my shirt just says hog. Like, that's kind of ridiculous. So that's awesome. What's up, NMBB? How you doing? Let's see, Major 70th. Nice. Pump for today. Great for Australian time zones. Hey, that's awesome. Great to hear it. I'm pumped for today, too. Let's see. The course still isn't out. I want my money back. Listen, equal slashed. I will give you your $0 back, all right? I will refund you all $0 that you are entitled to. Oh, man. Let's see. Cool. Good evening. Yo, what's up, Eno? How you doing? Ooh, that's going to come through my mic and the desktop audio. I didn't even think about that. I'll have to come up with a better solution for that. Too much AOC, not enough laundry. Dude, okay, like for real though. Like, literally, my days recently are just work, normal job. Go to doctor's appointments. And I have like YouTube channels that I like to catch up on. So like I have content I need to consume. I don't consume any programming pieces of content, but I do have like daily YouTube channels that I like to watch. So that takes time too. So, you know. Let's see. What's the type of advice you'd give for someone that wants to be like you, but is running a 9-to-5 job? Haha. So Gustavo, I'm also running a 9-to-5 job. So I don't know if I could give you much advice there. Like, you'd have to, I guess, specifically tell me what you mean by like, be like you. Like, so what do you mean specifically, like, be like me? Let's see. Glad I found your channel. I've been struggling if I should learn Bash or Python first, and your videos have opened my eyes up that Bash can actually be fun. Thanks for the content. Yo, I appreciate it. That is super nice. I love hearing that. Here's what I would say, though. If you're learning how to program for the first time, I love Bash. Learn Python. I mean that. Learn Python. On my channel, part of the fun of it is that I'm stretching Bash to do things that it probably wasn't built to do. Like, truly I am. And that's why I love streaming with Bad Cop too, because she does the same thing. She takes a completely different approach. She has a very novel approach to it. I really like it. I love making things that you really shouldn't. Like, Bash should have never been generating 3D environments, but that's the fun on my channel. So if you're learning how to program, I would definitely say start with Python. Like, honestly, I mean that. Yo, what's up? What's up in the Twitch chat? I've seen your username before. How do I pronounce it? Tufacho? Tell me how to pronounce that and I'll do it. Let's see. To be good like you, I mean, it's hard to run a product and delivering tasks from sprint to spring only. I assume you mean sprint to sprint. Yeah, appreciate that. That's a very nice compliment. The truth is, depending on your job, a lot of jobs, it's hard to learn at a job. They just want you to kind of do what you already know how to do, or maybe you learn enough just to do the job. if you want to get better, if you want to hone your craft, that's something you'll have to do outside of the working hours. Maybe you'll find a job that can let you do it there, but like if you want to actually get good at something, you got to dedicate some time to it. So you have to find time in the day, and if you don't have time, you have to make it. I can't help you any more than that. I know that advice sucks sometimes when people hear it. They're like, well, what am I supposed to do? It's like, I don't know, man. I don't live your life. I'm just saying, like, if you want to get good, you have to find time. So you got to go find the time. Like, I'm sorry, it's tough, but that's how it is. Yeah, let's see. Let me pull up the main layout real quick. So we have Advent of Code here, which is really cool. I want to, if Eric jumps in my chat, I want to point this out to him. I think it's really cool when I refresh the page that the snow at the top changes. The snow seems to be the only part is RNG. Oh, and the other little drops of snow and stuff change. That's cool. So as you can see, Puzzle 11 is out. It came out last night. I was not streaming last night. I just needed a break, you know. 10 is out, but we've only done 1 star. 10 is the one. I've had parts of it spoiled. Remember, if you're here, I don't want hints or spoilers for Advent of Code. I want to solve it all on my own. But I've had enough spoilers from people saying that they had to use linear algebra and some sort of Gaussian elimination to do it. Here's the benefit of, here's the cool part. I don't know what those things are. I know what linear algebra is, but I don't know what the Gaussian elimination is, and none of that even helps me. So the cool thing is they technically didn't spoil the puzzle for me. I still firmly believe that day 10 part 2, I can throw enough programming at it to get an answer. It might be slow, but I believe in my heart that it's possible. But for right now, we're not even going to focus on that. We're just going to do day 11 because I need something that could give me a small win. And I'm hoping, you know, day 11 is a little bit easier than day 10 part 2. That's what I'm hoping. So we're going to fire it in here on day 11, see how far we can get. And I want to be available at midnight, which is in 3.5 hours for me. When the next, I don't know why I did that calculation. It's right here. When the next puzzle drops, I want to be around for that. So I want to be there for when the last day comes out. Let's see. Has your brain recovered from yesterday? That was a whirler. Well, I wasn't streaming yesterday, but I think, do you mean day 10 part 2? And I did that with Bad Cop? Because no, my day is not. My brain is still not great. These puzzles have been absolutely tough, but they're just so much fun. They're so worth it. This is like, I just love these puzzles, man. I love these puzzles. That pop off when I got day 9 part 2. Oh my God. Nothing even compares to that pop off. I was so stoked. Let's see. We were getting some bitrate warnings from both Twitch and YouTube. I don't know why that happens. OBS says it's fine. We're not dropping frames. I think my network looks like it's fine. The stream quality looks like it might be just slightly too low. Will you guys let me know if the stream quality ever looks like it tanks? Right now, it seems like it's fine. I assume the stream's coming through just fine. But like I said, I'm also locally recording these, and I do plan on editing these VODs and making just like the parts where I solve the puzzles. Maybe, I don't know. Do people even watch those videos? I think people just either like the live experience or they don't. I don't know. I'll have to figure out if I'm going to do that. But regardless, I do have the local recordings, which is nice. But yeah, you guys let me know if the stream looks like it's bad or anything, because YouTube is complaining that I'm giving it a lower bitrate, so hopefully it's not the worst thing. Lower than the recommended bitrate. I might have to look into some of my OBS settings. AOC is also frying your brain. Dude, no, dude, I feel that, man. I only solved 1 puzzle. I suck. So I know my channel is called You Suck at Programming. I can just be like, haha, you do suck. Truthfully, I don't think you suck, man. I think you solved 1 puzzle. That's awesome. You solved 1 puzzle more than most people solve. So, like, the way you do all of Advent of Code is 1 puzzle and 1 part at a time. Like, I truly believe that, as cringe as like that might sound, like 1 thing at a time. That's how you got to do it. I'm going to pop open Discord, but I don't think anyone's actually going to be messaging me there. I guess I'll put I should put a notification in my Discord that I'm going live, huh? I'm really good at content creation. Yeah, my Discord is popping, man. I'm not used to it. It's crazy. Go to the announcements channel. Hey, yo, what up? I'm live now. Doing day 11 of AOC. Send. There we go. I would prefer a walkthrough of your solutions rather than an edit of the live, like your normal videos, but with the problems. Oh, that's a really cool idea. Ooh, I really like that idea. Oh my God. Yeah, I'm thinking of, here's a couple ways I could do it. Let's brainstorm a little bit. Because I could take edits of this VOD and then do a voice overlay. I could be like, yeah, so at first I decided to go with this solution. This is a depth first search type of thing. You know, I could start talking about that kind of stuff. And that could be really cool. I could also go a different route where I say, hey guys, today we're going to go over day one, part 1 and 2 of Advent of Code 2025. Now, if you're interested, I solved this live on my stream. The VOD is here for anyone who wants to go watch me problem solve this live and debug it. But for now, I want to talk about some of the approaches I took, how I worked through these problems, and how I would tackle these problems. Oh, that would be a good video. Like, for people who, like, do you want to get started with Advent of Code? Here's how I would tackle this problem. Now, I have experience in programming, and I know some data structures, but here's what goes through my head when I'm solving these. Yeah, I think I'm with you on that one, the second version. I think that's a good idea. Oh my God. Wow. You can't see, I'm pulling up my notes app. I have a You Suck at Programming notes app. And yeah, I'm putting this down in my idea section. This is great. This is great. AOC, walk through my thought process, each solution, and the bash specifics. So we can even talk about like now in this kind of example, I would want some sort of structured data. We don't have that in bash, but what we do have is 2-dimensional arrays that we can't nest, and they can store strings. So as long as we store the string there in some sort of way that we can serialize and deserialize, and what I mean by that is we'll just put data, comma, data, comma, data. Then when we get that string back out, we can turn it back into an array. We have to think about the performance cost of this, but for some of the problems, it's not that big of a deal. Oh my God, this could be great. This could be really, really good. I really like this idea. I would watch that. Yes, yes. Listening to Dave while reading Bash's source code. Bro, that's too much Bash. Second version is the thought process that are super valuable for learning. Yeah, thank you. I'm glad. Okay, awesome. This is, wow. That's an amazing idea. Thank you so much. And from a first-time chatter, what a good first-time chat. Incredible. No, but seriously, my God, I love that. That is such a good idea. Wow. Yeah. Can a bot announce that for you? Oh yeah, but you know, I never set that up. Oh man. Yeah, thank you, Random Logic. That's super nice. All right. Let's jump into it. Let's do some day 11 here. Like I said, we're going to skip part 2 of day 10 for now. We'll come back to it if we have time, but I know one's going to be a doozy. So let's get going. See, this deprecated syntax saves 2 bytes. It does, dude. The $ square bracket notation. Oh God, I didn't even know that existed. Jeez. Advent of Code 2025, day 11, reactor. You hear some loud beeping coming from a hatch in the floor of the factory, so you decide to check it out. Inside, you find several large electrical conduits and a ladder. Climbing down the ladder, you discover the source of the beeping, a large toroidal reactor which powers the factory above. Some elves here are hurriedly running between the reactor and a nearby server rack, apparently trying to fix something. One of the elves notices you and rushes over. It's a good thing you're here. We just installed a new server rack, but we aren't having any luck getting the reactor to communicate with it. My God, this is too much like what I do on a... This is my day job right here. I don't like this. Oh, man. Dark Space, I did not. I'll get back to... no, Dark Space, you may have just joined. I'm skipping over it. I'm skipping over day 10, part 2. We're going to jump into day 11 so I can get some wins here. I'm assuming part 1 will at least be somewhat straightforward. But with part 2 of day 10, my solution that I'm thinking of is some sort of DFS. I don't want to do the linear algebra because I don't know how to do it. I want to come up with a solution from first principles. So I'm thinking it's going to be some sort of DF. I'll give you a hint as to what I'm thinking. DFS plus some sort of heuristic to prune the branches of the graph, basically. That's what I think I'm going to do. I don't know if it'll be fast enough. That's my current thought process. I have more thought processes with... I've been thinking about this. I don't work on this stuff off stream, but you know, when I'm laying in bed, I can't help but think about it. I won't spoil it, but I have some Rubik's cubes and they helped me think of what I think might be a solution for day 10. But let's go back here. Let's go back. Let's not get distracted. Okay. You glance around the room and see a tangle of cables and devices running from the server rack to the reactor. She rushes off, returning a moment later with a list of the devices and their outputs. Your puzzle input. Cool. For example, okay, so we have all of these. We have something, colon, and then a bunch of stuff here. Okay, this just looks like a basic graph. Like, we've done problems like this. Each line gives the name of a device followed by a list of devices to which its outputs are attached. So BBDDE means that the device B has two outputs, one leading to device D and the other leading to device E. Okay, this is very simple. The elves are pretty sure that the issue isn't due to any specific device, but rather the issue is triggered by data following some specific path through the devices. Data only ever flows from a device through its outputs. It can't flow backwards. Okay, awesome, sweet. After dividing up the work, the elves would like to focus on the devices starting with the one next to you. An elf hastily attaches a label which just says you, and the ending with the main output to the reactor, which is the device with the label out. Okay, so we have a U and an out. Are there U and out here? Okay, so there's out here, and there's a U here. Wow, okay. This one connects to U? Interesting. Okay. Let's see. To help the elves figure out which path is causing the issue, they need to find every path from U to out. Okay. In this example, these are all the paths from U to out. Data could take the connection from U to B, B to D, D to G, and G to out. U to B, B to D, D to G, and G to out. Like, this is deceptively simple. In the total, there are 5 different paths leading from U to out. How many different paths lead from U to out? This is going through a graph, depth first search, and finding every possible viable solution, right? Like, this seems really, really simple, which has me scared for part 2. Are there loops? There can't be loops. I don't think there should be loops. If there are loops, then there's multiple. Like, if I could go from U to A to out, but then I could also go to U to A to B to A to out, then I could loop twice, and that's a third one, loop this way, and that's a fourth one. I'm going to assume there's no loops. I might eat that later, but it sounds like I'm going to assume there's no loops here. It sounds like quantum beam splitters. Yeah, it sounds similar to that. Yeah, this just reminds me of puzzles I've dealt with in 2024. But yeah, let's go ahead and get started here. So we have day 11. We have nothing in day 11. That's awesome. Let's vim the example, input.text. I'm gonna go over here and triple click the input, which highlights all of it on the web browser. That's a cool little fun thing if you have JavaScript enabled. Let's vim the real input.text and unshare that because this is my secret input that you guys aren't allowed to look at. And ooh, okay, that's a lot of input, and some of those have a lot of connections. Okay. So here is what we have. The example input has 10 and the real input has 591. Not a big deal. That's fine. This does not seem good for part 2. Or wait, could day 11 be super easy because day 12 is going to be impossible? I don't think he does it like that. I think part 2 is going to be tough. Your secret input's MD5 sum starts with a C. Sure about that? Yeah. Positive about that one? So dumb. That is so I believed you, dude. I thought there'd be like something clever and they'd have some sort of like I don't know, like MD5 is not that sound, so I wouldn't be surprised if there was some sort of like collision thing going on for fun. But like, dude, if you just straight up gambled, I respect that. That is so dumb. All right. Let's get cranking on this. Dude, imagine if you were right, I would think you know something that I don't. I would think that there is some like secret here and all the inputs have to look like something. Like I would think you're on something. Why did I call it part 1I? Did I call it part 1 and try to go to insert mode? Is that what happened? Am I missing part of the shebang? No, okay. So part 1 is here's what we're gonna do. We are going to Dijkstra path-based route. Yeah, pretty much. We're just gonna not even find the shortest path. We're just gonna find all paths. So we're just gonna depth first search. We're gonna DFS through this bad boy. So we have to read all the data in. Here's a cool thing we can do in Bash. We can say while IFS equals colon, so we're going to split based on the colon character. read dash r, what are we going to call it? Key value, do, done. And we're going to store all of this in some sort of key value store. Let's see. Oh yeah, fine. What's the second character? I just make him give me the MD5. That'd be so funny. Not a programmer by trade, network engineer. Hey, dude, listen, there are, I don't know if you've been doing Advent of Code, but there are some Advent of Code ones that are very like network heavy. I remember one last year that was literally for a LAN party connecting networking computers together. So like the networking guys definitely have like a leg up when it comes to that kind of stuff. Let's call this our map. Let's initialize it to be empty. And let's say map $key, which is the thing to the left of the colon, equals value. This is the thing to the right of the colon. Now there will be spaces, so this whole thing will be in there, but that's good because we'll break it on spaces later. So yeah. So now we have that. So now we can var dump map. Let's go ahead and import var dump. Var dump is so good that even Bad Cop has been using it. So I'm proud of that. Pipe that into part 1. Okay, so cool. We got the data in. That's awesome. And now we have to go from you to out. So we need some sort of function that will let us DFS through this. So we'll need like find path. Let me imagine how we're going to call it, because this actually starts it. And we need to keep track of how many paths there were. So total equals 0. We'll need something like that. So total equals 0. Find path. At the end of it, we can say there were total paths found. Does prompt engineer count? No, I don't think putting the word engineer at the end of random words doesn't count as being an engineer. So what do we want to find the path with? We have a starting position. We're going to start at U, and our goal is out. So we're going to try to go from U to out. And I'm being a Pokemon engineer right now. That's awesome. And then I think we need to keep track of, because we're DFSing down, we have to keep track of every step we make. So U and 0, we'll say. So local us, where we are, name equals $1, local steps equal $2. So that's how many steps we've taken, or paths we've taken, or something like that. Wait, do we even need to keep track of the depth? I don't even think we need to keep track of the depth we go, right? We just need this and a thing. So let's get connections. Local connections equals the map at name. And let's read that into an array. So let's say local connections, IFS, no, we're not gonna set it. Read dash RA, so read into an array connections from that string. So remember that string is something like this. We're gonna read this into an array. So at the end of it, we'll have array spot 1 is CCC, array spot 2 is FFF, and array spot 3 is III. So, yo, what's up? Hello, how you doing, Fallen Learns? Welcome to the stream. All right, so we're gonna read that. So let's var dump connections here. So this should loop through, those are the connections that U has. So U is where our starting point is. It's connected to B and C. So now we have to check find path of all the connections. For connection in connections, do, done, find path, connection. That's all we have to do. And then we just need to know when we hit our goal. If name equal goal, then total plus plus and return. We're done from this function. Is this it? Like, this is it, right? I don't think it's any more complicated than that. Oh snap, I'm on Twitch now. Yo, welcome. Is this just gonna work? If this works, the answer should be 5. There were 5 paths found. Like, wait, there's no trickery here. Part 1 is deceptively easy, right? This is just basic DFS, depth first search. Cat the real input, pipe it into part 1, 413. I'm so scared of what part 2 is going to be. That's the right answer. You are 1 gold star closer to decorating the North Pole. Hey, cool. Awesome. Wow. All right. Sorry. I'm just trying to. Wow. I mean, we got the answer. It just. Wow. Cool. Oh, man. We'll have me using FFTS and DAX. I don't know what. Wait. You're talking about audio stuff? Like fast Fourier transforms and digital. Is that what you're talking about? Oh my God. Digital analog converter and I was like, I stared at. Okay. You can't see it. I have a, what is it? My Focusrite Scarlett like audio thing down here. So I basically have like a DAC effectively plugged into it. Not technically a DAC. That'd be digital audio. Well, I guess it is. It is technically a DAC, isn't it? It's like a sound card. I think it is. That's just so funny. And I've written code to take a wave file with FFTs and like make like a waveform from it, which is really cool. I thought you were lying. I'm scared now because I know how complex this stuff can get. Like I've done this stuff, but it was a long time ago. So I don't expect much of that knowledge to be there. Thanks in part to your analysis, the elves have figured out a little bit about the issue. They know that the problematic data passes through both DAC, a digital audio analog converter, and FFT, a device which performs a is it fast Fourier transform or is it like Fourier transform? Fourier transform? I don't know how to pronounce that word. They're still not sure which specific path is a problem, and they now need you to find every path from SVR, the server rack, to out. However, the paths you find must all visit both DAC and FFT in any order. Oh, okay. Did that example output change? The example input change, I think? The example input did change. Okay. As in way. Fast. Is it Fourier or Fourier? Like, do I pronounce the R too? Is it Fourier? Or fast foray? Like my foray into pronouncing this? I don't know. I could just like look up how to pronounce it too. I'm just kind of being stupid. I'm just saving this as, we'll call this input, we'll call this example input part 2. Fourier. Fourier. Okay. Fourier. Okay. Does that sound right? Am I saying it right? Fourier? For EA Sports. It's in the game. All right. Cool. Perfect. Awesome. This new list of devices contains many paths from server to out. However, only 2 paths from server to out visit both DAC and FFT. Find all the paths that lead from server to out. How many of those paths visit both DAC and FFT? Okay. So I'm thinking the brute force solution, but there's going to be a reason why that doesn't work, right? CP part 1 to part 2. I also have example input part 2, so we have that to work with. Let's vim part 2, and let's change, let's do start equals SVR, goal, nope, let's be consistent. Goal equals out. So we have goal, let's change that to end. And we have start. Okay. Part 2. There were 8 paths found, which makes sense because when I look at this example here, there are 8 paths, but we only want to consider a path if it has seen DAC or if it has seen... Oh, no, it has to see both of them. Both DAC and FFT. Okay. Okay. They can't visit the same one multiple times, right? If you visit FFT, you're not going to go back to FFT. That wouldn't make sense. You'd have a loop. So we could just increment a number, and when that number is 2, then we know that it's 2 paths. So let me explain what I think of. So we have the 8 paths that it finds, but only 2 of those are valid paths. We need to store some metadata information, which is this number. If num equal, let's just say, well, let's just do equal 2 because it should only ever be 2. Then we'll increment the total. So if name equals end, and I'll explain what I'm doing here. I'm doing a little bit of out of order how I normally explain things. So we're going to loop the connections. If our name... So if we're at the end, if name is end, and the number is 2, remember the number starts at 0. If the number is 2, then we know it's valid, meaning we visited 2 places we care about. What are those places we care about? Case name in. The first one is DAC, and the other one is FFT. If the name is in either of those 2 things, then we will say num++. So if we're currently visiting DAC or we're currently visiting FFT, we'll increment the number. That way, by the time we get to the end, the number should be 2, meaning we've seen both those. So if I run this again, we should get 2 paths found. Not quite right. So let's go ahead and figure out what I am doing wrong. Oh, I'm not passing. I'm not, when I call find path here, I need to call find path with the number. I need to pass that information along. There we go. 2 paths found. Okay. So let's go ahead and head over here. The chat's being really quiet. I am so scared to see what actually happens when I give it the real input, because I imagine nothing works here. I imagine it will just take too long. I don't have any sort of prints or anything, so... So this probably won't finish anytime soon, right? All right. Let's see what's going on here. Yeah, the same input. You need a real input first? Nope. The heat death of the universe? Then yes. Yeah. So, yeah. Let's go ahead and let's get an idea. Let's just get an idea of how deep in the path we are. Let's store a depth variable too. This is just for us. This is how deep into it we are. Did you copy the real input for part 2? The puzzle input didn't change, did it? I have the real input for part 1, but I don't think the puzzle input never changes, I don't believe. Yeah, although it hasn't, like, so even though there's different example input, that sometimes happen. It'll say, although it hasn't changed, you can still get your puzzle input. So that's the kind of nice thing about these Advent of Code puzzles. They don't actually change. No, you're good, dude. You're good. Sometimes, this is what I've learned with Advent of Code, sometimes the example input will change, but the puzzle input never changed. I've never experienced one where the puzzle input was different. I should have the answers print to a receipt printer. That'd be awesome, actually. Yeah, the puzzle input never changes, which I think is pretty cool about these puzzles. So let's get an idea. Okay. And here's the deal with the real input. Like, there's not many connections, right? Except for this. What is this? What is this? So the connections blow up pretty quickly. So we're going to have to come up with a different way of doing this, I think. There's probably a clever way to calculate how long it'll take. But yeah, there's got to be a different way to solve this. So we're going to have to think. We're absolutely going to have to think here. Now, I'm going to start spitballing some ideas here. We need to go through DAC and we need to go through FFT. That means we could run part 1 on this puzzle, and we could say the beginning is SVR and the end is FFT, and we could give every path that goes to FFT. Then we could say the beginning is SVR and the path is to DAC. We can get every path there. Then we could say, give me the path from FFT to DAC. Let me write this down. I don't know if this is viable. We're writing down notes here. So we have to go SVR through FFT or DAC through the opposite one. So DAC to FFT, out to out. This is what we have to do. So we could figure out all paths SVR to FFT, all paths of SVR to DAC, all paths of FFT to out, all paths of DAC to out, and then we need to figure out all paths of FFT to DAC and all paths of DAC to FFT. Now here's something cool here. Let me think. There are no loops. So that means, I think, there's no loops here. So notice that we have FFT and we have DAC, but we don't have DAC and then FFT. It means that one is going to come before the other one. Like we're going to be able to hit FFT and then DAC. But if we hit, for example, if we can go from FFT to DAC, that's the order we have to do. If we can't get there, then something's wrong. So we're going to have to figure out real quick which direction we're going to have to go. So we're either going to be able to go from FFT to DAC or DAC to FFT. So let's go ahead and let's modify part one to take two variables, a start and an end. So we'll call it, I'm not sharing my terminal. We'll call it find paths. So we'll make a modified script called find paths, and we'll take the name of two variables that we want. Do you know that there are no loops starting with SVR? I don't know that. I don't think there is. So I'm going to go by what I said at the beginning. I'm going to operate as if there are no loops. I don't believe there could be loops, because then you would have like infinite number of paths. Okay, hold on. Pause. There might be loops. There were no loops in part one, but part two could be using totally different connection names where they don't even overlap. And so the part two connection names might actually have loops. We'll see. We'll see. I'm operating on the assumption that we don't have loops, but we don't know that for now. We'll take these as arguments. The question mark at the end of it just means that the script will blow up if I don't give it arguments, which is super nice. So let's cat the real input. And, well, no, let's cat the example input part two. Pipe it into find paths. And it will yell at us because I didn't give it parameters. We need a begin and an end. So what we're going to do is... I thought you didn't want help from the audience. I don't want help from the audience. No, Darkspace is good. Darkspace is not giving me help. He's just asking like questions. I'm okay with people asking questions. I'm not okay with like leading questions. If someone's asking questions in a way where they're trying to lead me down to find the right answer. So I'm okay with that. But like, I assume Darkspace, when he says certain things like this, first of all, I do assume Darkspace is usually messing with me just because like he was here last year. I understand. But also Darkspace does a good job of just asking legitimate questions. Like, do you actually know this? And it's like, well, maybe I don't know this. Doesn't mean I have to do anything about it. But like, I like to actually stop and take inventory and be like, wait, do I know this? So let's go ahead and do this. Let's go from SVR to FFT. There's one path found. Yeah, there's one path found. SVR, AAA, FFT. Let's go from FFT to DAC. There should be a path. Let's go from DAC to FFT. Look at that. Look at that. Look at that. Okay. These are just names. Yeah, SVR, FFT, DAC, these are all just names in the puzzle. Like if I cat the example input part two. Now they all have like clever little cute names. Out is meant for like output, I assume. SVR is short for server. It said that in the puzzle. And FFT is the fast Fourier transform. And the DAC is for the digital analog converter. But like they're just names. Like you don't have to think about them. They're just like variable names. So there are 0 paths there. Okay, cool. Let's go and find the real path. I don't know if this is even a viable thing. Let's find all the paths from DAC to FFT. There were 0 paths from DAC to FFT. FFT to DAC? Well, there's going to be a path. But we already know. Look at this. we know that we can't go from DAC to FFT. So that's good. That's a really good thing to know. Whatever our paths are, we are going to have to go SVR to FFT, FFT to DAC, DAC to out. We are going to have to go there. It's like the robot maze puzzle. I remember that puzzle. That was a fun one. TTY2 is clever. Oh, that's cute. I didn't even notice that was one of the input names. Let's see. Hey there again. I'm still stuck on day 10 part 2. I skipped it for now. Like, don't look at my stream and be like, oh, Dave solved it. I skipped it. I just absolutely skipped it for now. I wanted to go in a puzzle that we at least had a chance of doing. So, again, I don't know if this is going to finish in any sort of meaningful time. So, we might have to start caching things. I don't know what we can cache. But we might have to start caching things. I am using iTerm 2 on Mac OS. Imagine not getting 2 stars today of the puzzle. Yeah, listen, man, I don't know how to do linear algebra, so I got to come up with a different solution for that. Howdy, Dave. Yo, what up, Kirby? How you doing? Let's put some other things here. Let's put the path here. So put an empty string here. There we go. So that's the path we've taken. Okay, so now when this runs, it will print the valid paths. So let's go ahead and run this with the example input. So if I find paths from DAC to FFT, there's none. But if I swap those two, oh, nope, using the wrong thing. What is it? Is it Option T? There we go. FFT to DAC. We can see that there's one valid path. FFT, CCC, EE, DAC. That's our valid path. FFT, CCC, DEE, DAC. So that is the valid path. So we have an algorithm to get the valid path and print it out, which is super nice. So we can start constructing it. We just need to do some other things. So we have our real input. We're trying to find that one. That one was very slow. So we know that we have to go. We can't go from DAC to FFT, but we can go from FFT to DAC. So we know that. So if you're not too locked in, I'm pretty good right now. I was meaning to ask if you're going to tackle past year's AOC, any idea what you'll do next? Start at the beginning of 2015 or do the encode thing for 2019? Yes, I do have plans on doing that. I don't know exactly when it'll be, but I want to because these are so much fun. If I do that, which I will, it's going to be like January, February when I start doing that. I will start with 2015. That's my plan. I just want to go through in order. The encode stuff sounds fun, but I just want to go in order. So that's how I'll be doing that. I love that there are no paths from DAC to FFT, keeping some realism in the puzzle. That's kind of cute. You know, I mean, it is Eric. I wonder if that was considered. How's your exactly? Listen, we're getting there. That's how it's going. The test input had 2 paths. The test input had 2 paths from server to out, but 1 path from FFT to DAC. So server to out. Help if I put the right arguments. This will have 8 paths. There's 8 possible paths, but only 2 of them are valid. So if I pipe this to part 2, there were only 2 paths found. So it's very confusing. These are all the possible paths, but these are not necessarily the valid paths, so they don't visit FFT and DAC. So yeah, we're doing some stuff here. Thanks. Yeah, no problem. Hi from Russia. Thanks for the content. Yo, appreciate it. Welcome. So here's what we know about our puzzle so far. We know that we have to go from FFT to DAC. We can't go from DAC to FFT, but we have to check these other routes now. So let's cat our notes and let's go ahead and find some other paths. Cat the real input, pipe it into find paths. We want to go from, let's say, FFT to DAC. So we need to go, oh wow, if we know this, we know what path we have to take. What am I doing? Yeah, if we know this, then all paths gets really low. We can't go server to DAC, doesn't matter. We're going server to FFT, FFT to DAC, and then DAC to out. This is where we're going to go. Okay, these are the 3 paths we have to find, and we have to find all the possible paths between them, join them together, and we're good to go. So we've cut down the amount of stuff we have to do, but I still don't know if it's going to be, possible. So let's find paths from server to FFT. There's one path. Oh, I'm in the example input. I was like, there's definitely going to be more than that. Now, this could take some time. This absolutely could take some time. So we're probably going to have to come up with a better way of doing this. I'm thinking. So we're trying to go from server, which is the beginning, to FFT, but data can only flow in one direction. So I'm wondering if it makes sense to try and go backwards. Because if we start at FFT and then figure out how many ways to get to server, it might be easier. Because then, let's just imagine this. If we start at FFT and we want to go to server, cat the real input, grep for FFT, there's not many things we have to do. So if we want to go to server, we start at FFT. If we want to go backwards, we can go to YJB, we can go to ZHK, or we can go to QXB. It might be faster to go backwards. So let's CP find paths to find paths backwards. Find backwards paths. This might be something. It could be nothing. This could be nothing, but it might be something. So in order to do that, we start at the place that we're beginning and we're going backwards. In order to go backwards, we don't want to 7-day stream. Yo, sup, Narf? Lucky number 7. That's what I like to hear. Here's what we want to do. I mean, we might want to go backwards. I haven't thought about this. How are we going to implement this? If we're going to find every path, let's imagine we're at FFT, we're going to find every path. We don't want to look at the connections to FFT. We want to look at every connection that has FFT in it. So, let's do this. Let's put spaces around this, and then we can do a simple wildcard match. So we have the connections at map name. This is a space separated list with spaces at the beginning and the end of all the connections we have. Oh no, I see what we have to do. Okay, we have to loop over the map. For device in map name, the device name is the key. Do the local device connections. The connections equals the map at name. Now we have to say if the name we're looking for, if the connection string is equal to star space the name we're looking for star, so that means it's somewhere in that, then we're going backwards through the list. Then find connections of device and my brain's fried. Give it path. I think. So this should give us the paths backwards. I don't know if this is gonna work. Cat example, part 2, pipe it into find connections, find paths from SVR to out. So this is the right way of doing it. There are 8 paths. Not all of them are valid, but there are 8 paths. Let's go ahead and find paths backwards, or find backwards paths of out to SVR. Okay. Oh, all of them. Okay. Now we gotta do some debugging. We're beginning at out, and we're going to SVR. Okay, so if we're beginning at out, so we have to look through every single possible connections. That should be device. Well, I called it find connections, and we should probably call it find paths, huh? Is that syntax the name of the keys? Yes. Yes, that is how you get the keys of an array, both indexed and associative array. So for the associative array, we'll get the string keys, but for an index, you would actually get the numbers. And Bash has sparse arrays, if you didn't know. If anyone was watching this, you can make sparse arrays. So you can have an array with spot 0, 1, and then like 45. It's kind of wild. So we're looping over. I'm probably just doing something really stupid here. Let's start thinking. We're just going to toss some debug here. Love hanging out with you and Bad Cop, learning tons of bashism I never knew. Listen, together, her and I like have way too much bash knowledge. Like even alone, we have too much bash knowledge. But yeah, that's super nice to hear. Let's see. I like to watch Dave picture in picture and pretend he lives inside of my terminal. That's awesome. Do you ever use set-ex for debugging in Bash, or do you prefer a more printf-based debugging? I have a whole video on why I don't use set-e. I will use bash-x for some debugging, but honestly, I just like the printf-style debugging. I have yet to find something better. Bash-x can be useful sometimes, but... Well, okay, maybe because I should just really just name things the right thing, shouldn't I? Hey, look at this. There were 8 paths found. That's correct. And this is going backwards. So in order to get from out to SVR, you would go through this path, but what that really means is from SVR to out. So it might be faster to check this backwards, because we're kind of dealing with diodes. So I don't know if it's gonna be faster or not. This is like solving a maze backwards might be faster. So who knows? Let's see. Hi, I follow your content time to time. Yo, thank you, welcome. I got a question. Have you exploded analog computing? Like, have I explored it? No, I have not. I haven't looked too much into that. I think it's cool stuff. I just haven't had much time to look into that. Cool, I have to watch it. Yeah, I forget what I call it. I think I call it like Bash strict mode. So if you search that on my YouTube, you'll find it. I put it out a couple months ago. I feel like half the time I use -x, it just tells me where I need to add printf to actually debug it. Yes, exactly. Sometimes I'll do, I think Bad Cop does this too. I'll do this. I might do like set -x, set +x, and then I can see all variable declarations, which is kind of nice. I can be like, okay, this variable is set to this. That seems sane. I can quickly spot like sort of crazy things like that. So I have been known to do that from time to time. But this is really cool. Now we can find things backwards. What about photonics using light to compute? Nah, I never looked into that stuff. I don't know much about it. Sounds cool, but I don't know anything about it. Find backwards paths. Okay, let's look at our notes. So we have to go from SVR to FFT, FFT to DAC, and DAC to out. Okay. So find backwards paths of the real input, and we want to go from, let's say, FFT to server. Okay. I have an idea. I don't know how much this will... Okay. I have a really good idea. I think we just come up with every backwards path, and then we prune out the ones that have the same thing. So we combine them all together into a giant string. We have something here. We'll work through this one by one. Okay. Here are the paths from FFT to SVR. Now we need to go from FFT to DAC. Remember, we're going backwards here, so it says DAC to FFT. We're going FFT to DAC. We're cooking here. Whatever you end up doing, it has to be cooler than what Bad Cop did. Dude, I don't know. Like, I love Bad Cop. She is great, and I consider her a friend, and she's wonderful. I don't understand how her code works sometimes. I don't think she does either. I look at some of the like code she comes up with. I'm like, bruh, like what? What is this? Like, you are like a I don't know, an artist when it comes to code. I am not like an artist when it comes to code. I am so painfully methodical. Do you like keyboard-driven tiling window manager, i3 for example? They're cool, but I'm on a Mac right now, so I don't have anything similar to that. It's monkeys on typewriters? Yeah. Her golfing solution was crazy small yesterday. Oof. It always makes me, it doesn't make me feel bad. That's not the right word, because like I think it's cool that you guys tell me this. It just makes me feel like, oh my god, I can't believe I'm struggling with it when it can be golfed down so low. Oh man. So do you think this is going to resolve in any sort of meaningful time? They do have tiling windows on macOS. Yeah, I shouldn't have said that. That is true. They do have that. I don't have much experience with them. FFT to DAC. Let's go from DAC. Let's go from out to DAC. Let's just get an idea. You're using one called Rift. Is it any good? They always seem so weird. Like the accessibility API always seems so sluggish to me. Did you read on Discord how I solved 9-2? No, I did not. I haven't read most people's solutions. I just didn't want to like the advent of code chat. I don't want to look in that if I could possibly spoil anything, you know. Uses Core Graphics API apparently. Oh, okay, interesting. I'd have to check that out. Yeah, I remember like trying to install something a long time ago and to use some sort of like accessibility API, and dude, it was so slow, man. I don't even understand the code. Oh, I do like Rust though, so there might be a chance I can understand it. Although I should be clear, I like the way I write Rust. When I see some people's Rust code, I'm like, dude, I can't follow at all what you're doing. Like when I start seeing like generic associated types and types that expose other types, and I mean, it gets complicated quick with Rust. It's cool, but it gets complicated quick. So this doesn't seem good. Now hold on. Can we find the forwards paths from DAC to out? Okay, here's something fun. We can generate the paths from DAC to out by looking at them going forward. We can generate the paths from FFT to server by going backwards. So now we just need to go between FFT and DAC going in either direction. Okay, move find paths to find forward paths. Okay, now let's think about this. Because we need to find SVR to FFT, FFT to DAC, DAC to out. So one way we can do that, one way we can't, we should race them. Yeah, no, literally. So let me remember how to do this. If we find forward paths, okay. Okay, we find forward paths from DAC to out. So we'll call this DAC out.text. Okay, let me vim that. Is there anything BS in here? We have that line at the bottom we can get rid of. And we can trash this here. And we can also get rid of the ending colons. There we go. Clean this file up a little bit. So from DAC out, these are our paths. What is this? Oh, that must have just been an artifact of the terminal. That was weird. Yeah. 30 bytes is incredible for a solution. That is insane. Oh my god. I made a list of only the rectangles that had one of its corners as the rightmost point of one of the two really long lines. You looked for them? Like, did you visually look at them? You looked with your eyes? Ah, dude, I love that. Like, Bad Cop's not a big fan of the puzzles you have to look at with your eyes. I love them. I love when you have to think outside the box in that way. I find that so much fun. So we have 9,755 ways to go from DAC to out. That's awesome. Now we need to go from server to FFT. And I think we did that by going backwards, right? FFT to server. Yeah, I think that's how we did it. Now these are going to be backwards. So we're going to have to swap them. there an easy, that's where I need bad cop. Is there an easy way to just like take all those values by commas and just swap them? There probably is. I have to think about that. Let me write this out to a file. FFT to svr.text. That way we'll know it's backwards. All right. So we have these. They are going to be backwards. We'll have to rewrite them. Yeah. Do I really need to swap them? I mean, I don't know if that's what you're asking, but I don't even think you do, really, because I just need to look inside them. I don't actually have to follow the path. I don't really care about the path. I don't care about the direction of the path. I just care about what's inside the path, what stops we make along the way. Delete those lines, delete that line, and then... oh, you know, when I deleted commas at the end, I kind of made the assumption that all the paths were the same. I don't trust that first file. Yeah, actually, now that I think about it, I don't trust that first file because the way I deleted the commas at the end. We should be doing this. We should be deleting commas at the end like that. That's what we should be doing. So let's rm DAC to out just before I make any mistakes. And let's regenerate that one because that one was pretty quick to generate. Yeah, I don't trust the way I deleted the commas at the end because if there were lines longer that I just missed, they're gone. There we go. Okay. So word count dash L star FFT and DAC. Okay, not bad. Not bad. We have to filter the ones that have the same ones. Okay. If you really want to reverse the list, TAC is the way. Nah, I wanted to... you can split into lines, TAC. Yeah, I could. I don't really need to. Yeah, because what I would do here... I mean, like, there's probably a way faster way. I would just do it with bash, honestly. While read dash RA, I can read it in like an array. I could say ifs equals comma read dash RA array. And then I could... Oh, wait, no, I have to reverse the thing. How do you reverse in bash? There's a way to... Well, you just loop over the array backwards and print each element. It'll be slow. There's no reason to do it. It actually doesn't matter because we're going to filter out the ones that are the same. Okay, I haven't thought of the way to do it yet, but let's do this. So now that we have our notes, let's find the forwards paths from FFT to DAC of the real input. Now let's write down to FFT-DAC.text. And let's at the same time open up a new window. Who knows if either of these will finish quickly. And we'll find the backwards path of DAC to FFT. And we'll write that out to DAC to FFT.text. So those are different files. Start and start. Okay, should have timed them. So we'll have to figure out which one is faster. All right, we're cranking a little bit. Not too bad. I gave up on 11-2. I have a solution I'm 99% certain it would work. It's just one of those that would require a massive amount of memory. Yeah, dude. I know that feeling. Sometimes the hardest part about doing them in bash is sometimes I wonder, like, is this not working because of bash? If I had, like, Rust or C, would it work? Because sometimes the answer is yes, but most of the time the answer is no. Most of the time it's like, this is just not a feasible solution. So going forwards and backwards is not quite working out for this. Let's open up a third terminal, cd dev, add window code, 2025, day 11, ls, word count dash la, nope, word count dash l, what am I doing? DAC and DAC, okay. DAC to FFT and FFT to DAC. Well, FFT to DAC found at least two. I mean, it's still running, but it got two solutions. So if we go from FFT to DAC, it's not the end of the world. And then what we'll do is you combine all the inputs together. We loop through the 3 text files of inputs we'll have at the end, which I believe are what, 15,000 like long? Like, no, 5,000. Okay. And 10,000. and then you join them all together. So for the, like, when you loop through 1,000 of them, 10,000, you try to tack on the next 2 lines, and you go through that list, and you go through. That's painfully slow. There's got to be a way faster way to do this, but we'll get to that when we get to it. Yeah, the nice thing about this solution, we're not going to need memory. We just need the disk space to be able to hold all the information. I don't know if this is going to run in any sort of meaningful time, though. Hey, we got 5 now. And this is, I mean, the reason is it's just the depth. But this isn't the end of the world. Like, it's not that deep. It's really not that bad. We could start pruning these lists. Also, this is cool because it's depth first search. We can kind of get an idea of how deep it is. So, like, that is, yes. You are right. That is also assuming that the third file similar size and line count. That is true. We are assuming that. There's no chance that it is. I mean, look at how big these paths are. I'm willing to bet that it's going to be a lot bigger. Yeah, I'm doing mine in Lua, and sometimes stuff just takes a long time to compute. Yeah, exactly. Like, I'm just worried about that. Now, here's the thing. Here's what I'm thinking. Oh, wow. The DAC to FFT got one. Oh, wow, and it's significantly shorter. We could do some processing on the files we have. So, for instance, we have... Which one goes to server? FFT to server. We have this. Now, we could do some filtering on this. Some optimizing. Like, ZHK is in there. This isn't going to work. Hold on. Yeah. I was trying to see if there was one that's in, like, every single one. Like, if ZHK showed up in every single path, then we could filter out, but it doesn't seem like that's the case. Yeah, I'm gonna have to think about this one. This one's not instantly jumping out to me. I just arrived. I don't have any idea what's going on. Hey, you and me both, brother. No, that's not true. So I think this one might be a little bit too slow. I'm picturing this, okay, visually, I'm picturing this, visually, I am picturing this like a waveform, like literally like an actual waveform. Like, server is here, out is here. There's going to be a bunch of branching paths so the waveform gets really big, but it's going to collapse all back down into DAC or FFT, whichever one comes first. We know whichever one comes first. Then it's going to get really, really big. And it's going to get back small again to FFT or DAC, and then it's going to get really, really big with all the possibilities, and it's going to get really small to out. That's how I'm picturing it, and I'm trying to do work to capitalize off of that, but I don't know... I don't know of any way to simplify that. This is iTerm 2 on my Mac that I'm running. Are these hard for new programmers? Yes. Yes, if you're a new programmer, I don't know if I would recommend Advent of Code to you. If you're trying to learn, I don't think this is a great way to learn. I think it's a great way to hone your skills, though. Like, I love these coding puzzles, but these are hard for seasoned programmers. But the thing I'm dealing with now is, like, I can make the program do what I want. My brain just doesn't know what I need to have happen yet. I solved this one really late last night. Never had such a big high from the puzzle. Dude, I feel that. Have you seen my pop-off from day 9, part 2? Dude, I crushed it. I was so pumped. Oh my God. I've been programming for 30 plus years, and some of these puzzles have broken me. Dude, that's why I love them. I love these puzzles so much. Oh my God. It's like the best feeling though, because they break you, but then when you get the answer, it's like, nothing beats that feeling, dude. So I'm going to have to come up with a different solution for this. I don't think this is totally viable. Maybe I just study the files and see what I can glean. Because this might be one of the situations where I'm not going to try and go for a generic solution right now. At this point, I just want to go for like a solution. You know what I mean? So let's see if we're going to go from FFT to server. Wait, that's it? That's not right. Wait, is that what I'm calculating? No, I'm not. How many lines was that? Oh yeah, 5,300 lines. Okay. If you're just starting, it's still worth trying them. Yeah, like definitely try them. And that's the other thing too. Sorry, I totally projected my own worldview, which is I don't want any hints or help from someone else. If you're learning programming and you're open to getting hints and talking to people and getting advice, these would be great ways to learn. Sorry, I totally projected my own way of doing these puzzles onto you. So I'm glad you brought that up, Narv. I haven't solved either part of day 8 nor part 2 of 10, 11, and I don't think I can. I don't know if you can or can't. I don't believe in saying that you can't just because I think like anyone can solve anything. But I do low-key feel a little bit about that way with day 10 part 2. So I'm just going to be real with you. But like I try not to let that stop me from trying. You know what I mean? See, earlier days and part 1s are good if you have some experience and want to develop additional problem-solving skills or file parsing. Yeah, definitely. So if we go from FFT to SVR, FFT is always going to be the same at the beginning. So what we could do is let's grab field 2 separated by commas, and then let's frequency count that. Okay, so the next jump after FFT is going to be you either go to YJB 900 times, you go to ZHK, or you go to QXB. You have to go to those 3. So if we're testing the YJB route, we can throw out any of the answers that have YJB in the final files. And with some clever grep, I mean, I love my pure bash solutions, but with some clever grep, we could probably do that. Because if we were to look at our out, our DAC to out, and pipe that to word count -L, there's a lot. But if we grep -v YJB, there is the exact same. Right. Yeah, no, of course. Wait. Yeah, how would YJB ever be it? There's no loops, I don't think. So you just multiply these number of puzzles together. Yeah, like let's say there's 1,000 ways to get to DAC from server, there's 1,000 ways to get to FFT from there, and 1,000 ways to get there. Then you have 1,000 times 1,000 times 1,000? Is that right? I might have to do some math, but yeah, I think that's right. Yeah. Yeah, exactly. If there's 3 ways to get here and 3 ways to get here, that's 9 total ways. Oh my god, I'm addicted to slot machines. You think I would know that? Okay. So if I can get this answer, if either one of these finishes, I have the answer. If they finish. Now, I don't think there's a chance they finish because, like, all of these being the same all the way up till this point is bad because it gets exponentially more difficult to get here, to get here, to get here, to get here, to get here. And this is a depth first search. So, like, we're having a bad time here. I could parallelize this. I feel like math is our friend here. think math is our friend here. I think caching. I have to think about this. Because, like... Oh my god, it's caching. It's caching. It's always a caching problem, isn't it? It's always a caching problem. Once you hit R and U, we just... Yeah. Once we hit QIY, how many paths are there to DAC? 1. Once we hit MQY, how many paths are there to DAC? There's... Memoization. What am I, stupid? Sorry, I'm trying to be better at not doing the negative self-talk. Not because of like any sort of, I think it's messing with my brain, just because I don't want to project that onto my audience. But come on, what am I, stupid here? Come on. Yeah, which one was faster? FFT to DAC is faster. So the forward path is faster. Let's do that. CP find forward paths to find forward memoized paths. Streamer brain has to be even worse than interview brain. Okay, no, like for real though. Like, it's tough. It's tough being a streamer, guys. It's harder than your 9 to 5. No, I work a 9 to 5. This is infinitely easier. This is so much fun. But I don't. This isn't my living. So, but reading things as a streamer, I'm like reading them in a way that's like entertaining to listen to. Sometimes I don't comprehend the things that I'm reading. Like when you're announcing something, you're not taking in what you're saying. So it becomes problematic. I've read things, but like they haven't seeped into my subconscious. So thinking and doing and performing. Yeah, it's weird. One of the problems I ran into last year was just a misunderstanding how PowerShell does classes. Yes, like that. Oh, that screws you over when like the language feels like it's against you. It's brutal. All right, let's have a cache. I don't know what the cache is going to store yet. Yes, I do. If -n. Let's get the cache value. Cached equals, what do I call it? Just cache? Yeah. If cached equals cache at name. If cached is greater than 0, then I thought I knew Bash before watching these streams. Listen, Bad Cop and I make Bash do some really gnarly things. Total plus equals cached and return. FI. Otherwise, we check if we're at the end, then it's a valid path. Wait, how are we going to cache things? I'm not thinking this through. Hold on, I have to think. Because we don't know something's valid until we get to the end. I know this problem's easy. I can't think of how to do it. Because like I could scan through all the connections initially, and anything that's directly connected to out has a score of 1. And then I could calculate how many things get to that and get their score. We might have to go backwards. I have to stare at output to understand what I'm trying to do here. I'll be right back. I'm gonna go get a drink. Oof. All right, I'm back. Got a nice Canada Dry Zero Sugar Ginger Ale. Still can't believe he's solving advent of code using bash. Can't even solve with the real programming language with big int, hash mavs. Oh my god. Listen, man. It's not the tools, it's the carpenter. And bash is absolutely a hammer. So what am I, stupid here? Let me think. So we start here, we're doing DFS, and we've ended up walking down this path, and we verified it's a valid path. How do we cache along the way? We can store, we're trying to figure out, let's see. Do you think you'll make a video recapping your AOC 2025 experience? I don't have time to watch a lot of things, but I've been interested in highlights and retrospective thoughts. That's exactly what I'm going to be doing. Someone actually suggested that, so that's my plan this year. Instead of cutting up this stream and just putting it up, I plan on doing like going over the puzzles fresh, like talk about my thought process while doing the puzzle, what solutions I explored, how I did it, and how I eventually solved it using bash. So I plan on doing a video where I talk about that, like going over the solutions and how I would approach them. I think I'm going to do that. Yeah, that's my plan. Director's cut. That's a perfect way of putting it. Okay. Now let me think. So we're doing DFS. We get down here, we get down here, we get down here. None of this stuff is cached. Now that we have this, what do we cache? That we know of one path from this to get to DAC. Do we walk back up the path? Since we know this is valid, no, we can't walk back up the path because then this gets really large. Yeah, day 10 part 2 is going to be an absolute nightmare. I haven't figured that one out yet. That's why I'm skipping it for now. I feel like I'm overcomplicating this problem somehow. I don't know what I'm doing wrong here. Like what do I want to cache? I want to cache how many valid paths are. If I walk up this thing and figure out, okay, there's one path to DAC here. EOI has 2 paths to DAC. FYI has this many paths to DAC. And I can cache that, but then as I get higher, it's going to become a problem because now I look at RNU. How many does RNU have? Well, every single way RNU has... Oh, RNU has one path to... No, it's not one path. I guess the cache doesn't get simpler because everyone I have to space out a little bit more. I don't know, am I being silly here? You back up one and then you check how long it took, but you go into it. So like we back up to Mixer and we see how long Mixer took. Well, we have the cache for RNU, but we don't have it for OPZ, so we have to go down there and start building it up. I guess how do I know when to stop incrementing the cache and when to use it like a source of truth? I feel like this seems like an easy problem that I'm just completely over complicating. Yeah, I'm severely overcomplicating this. Let's use a simpler example here. There are two ways for FFF to go out. It either goes through GGG or goes through HHH. So if we work backwards, sorry, I'm just deep in thought. I'm overcomplicating something here. Or maybe it is a complicated problem. Like, again, no hints, no spoilers. No one's giving me any hints or spoilers, but just letting you know that's where I stand with this. I'm going to figure this out on my own. But like, we have a valid path from FFT to DAC. That's great. And we can look at OJU, and we can see that OJU has exactly one way to get to DAC. Of course, it's directly connected. It has a cache score of 1. When you hit OJU, there's one path. I'm holding myself back super hard. Yeah, like I feel like I'm missing something. You know what? Here's the annoying part. If I could turn off the streamer part of my brain and go into a dark room with my laptop, which is my ideal way of programming, I would have this. I'm trying to get out of entertainment mode just for a little bit, just to lock in mentally. EOI can go through OJU or can go through QIY. So once you hit EOI, you know there's two paths. You never even have to check OJU's cache value. Okay. I'm gonna overcomplicate the code, but I need to start making some progress. If there's no cache value, then we have to build the cache for it. Wait a minute. If we're at the end, then we're done. Now we're going to loop over all the connections here. And we're going to check. Oh my God. Okay. We're almost here. We're going to use some of Bash's new syntax, I think. We're going to check the cache. Check the cache, add the name. If it is set, then we are going to that value. Otherwise, we're going to build the cache. And at the end of this, we're going to echo the total. Else, if it's not, then we are going to find path. Yeah. That's what we're going to do. cache at name equals num. Okay. Okay. I don't know why I overcomplicated that. New syntax? Yeah, look at this. This is the new syntax. This allows us to run this command, but not in a subshell. So we'll get whatever the output of that command is, which is here. Oh, we also don't want to output that it's failed. That'll screw things up. We could use a different syntax to do that. Totally fair, but I'm going to give Streamer Brain some engagement for the stats. Ha! Appreciate it. Gotta run, family time. Happy hunting, Dave. Enjoy the streams. Yo, appreciate it, Nate, dude. That's super nice. Yeah, have fun with the family. Isn't it? You're right, Narf. You are right, Narf. That is what it is. That is what it is. You need the $sign there. I go over this in my bash course, which is coming out in the next week. When you see parentheses, pretty much assume there's going to be a subshell involved. When you don't see parentheses, assume that there's no subshell involved. It holds true for most of the syntax, but that's nice. No fork and exec is going to happen here. Well, in a subshell, it would just be a fork. But let's do total plus equals num. I think we might be okay. Which way do we go forward? Find forward memoize paths from SVR to FFT. Let's just try it. Is that how we got it? We have FFT to SVR. No, we did it backwards. From DAC to out. We know DAC to out will work. I should probably start printing some stuff too, because I actually don't know like if we're... Oh! It's also waiting for input. Okay. Well, yeah. Does the new syntax just improve performance then? Is there a reason to use the old command substitution yet? Yeah, a couple reasons. It definitely increases performance. The old command substitution is useful if you're targeting older versions of Bash, of course. But the other thing is it does create a subshell, so any variables modified in a function call will not be modified in the parent shell. So that may or may not be what you want. So depending on what you want, you might want to use the old syntax. So like, for example, like when this anything that this find path function modifies, it will be modified in my parent shell. So I have to make sure I'm doing a good job of putting the local keyword everywhere. Which I am. I'm pretty good about that. I'm not. Wow. Yeah, so that'd be like one reason to not use it. Total plus equal cache. Let's hope if I got my syntax right. Okay. Declare -a connections rup for you. What? Trying to do arithmetic expression on an array? What line is that? 37. Total 0. Probably don't want to do this. Oh, we just have a return here. Oh. When we're already at the end, then we just echo 0. What is happening? Why is it like printing a variable poorly? What am I doing wrong? Oh. What is happening here? What am I doing wrong? I'm genuinely so confused. Oh, I can't print this right, yeah. Do I have to do local minus A? What am I doing wrong here? This seems like something very, very silly. What is going on here? Why am I getting like set minus X output? Where did I do that? Where am I getting that? Why is it printing out the declared? Like I actually don't. What is happening? And why are they going to standard out? What is this? What's happening here? Yeah, that's like... What, am I crazy? What's happening here? This is super bizarre. What? You have local on a line by itself. Genius. Why? Oh my god, is it like running declare? It just prints everything that's declared? So local just prints everything that's local? Wow. Wow, thank you, Narf. Oh my god. Oh, that is so dumb. Oh, wow. Wow. No, that's not a spoiler. You're good there. I'm okay with people pointing out bugs. Oh, man. Oh, you were looking at that for 20 minutes? Okay, listen, sorry. I should be very clear. I don't want hints. I don't want spoilers. I don't want algorithm names. I don't want people leading me directions. But if you see I'm missing a $, or I have the wrong syntax, or I have some weird, like, that's fine. That's fine. I am okay with that kind of backseating. That's okay. I don't consider that a spoiler. Oh my god. Oh my god. I am upset. Don't you dare call me a bug, Darkspace. Oh my god, that's so funny. Well, at least we still get a bug. Why would it be dash n? We can be your linters, but not your chatbot. You got it. What doesn't it like here? Declare total as a 0. We're incrementing it here. I'm using consistent variable names. Cache exists and is a map. Connection is a string. Let's just do some checking. Okay. If cache is greater than 0, then we store it. So how is that a syntax error? Okay, that part's right. How are we getting down there so fast? How is that returning so fast? Find path takes a name. We're giving it the name right here. This should be a lot slower. The first find path shouldn't return, like, at all. Bro, what is happening here? Somehow it's just not returning the right number here. There's supposed to be a semicolon on the num equals line. Yeah. Yes, there is. That's what makes that syntax special and actually execute properly. Well, the fact that it returned 0, 0 is probably not great. Oh my god. Okay, well, that's still a bug. Looking forward to the next one? Yeah, definitely be streaming in the future. You listen to me type? Listen, love it. It returned 0. Oh, right, I can't just... Okay, I'm going to use a new syntax here that I really like, where you put a pipe here. Now the pipe says you don't look at what's being echoed, you look at what is being set to a magical variable called reply. This is new in Bash. So that way I can write to the screen without having my output gobbled up. So this function runs, and the output is whatever's stored to this magical reply variable. And that way I can safely emit things to the screen without having to explicitly go to standard error. Just to make our lives easier. So when I do things like this, it's not breaking. How is this one wrong? Oh, because I didn't put a $sign. Wish I did it last night. Well, hey, you know what now? I love this new syntax. I absolutely love this new syntax. Okay, so that's wrong. But, you know. Oh. Should probably return 1 here, right? We have to at least let it add up somehow. Okay. So, things aren't great. Oh, that. Okay. So we overflowed. Not fantastic. No, it's not a path, it's 0. We were doing DAC to out here, which we already have as DAC to out. We have 9,000, so we should be able to get 9,000 out of this, 9,755. So we're just having some little variable thing. We just have to actually like increment at some point. If there is a cache value, then we store that cache value. Otherwise, we call the function again. So at some point, this function has to return like that we made it. So I'm doing something wrong. Just real. It's real obvious what I'm not. I'm gonna stop trying to talk. It's a simple bug again. So this is clearly not the right answer. I'm doing something wrong. I actually need to start. I'm retrieving a cache value that I never actually properly cache. There's no 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 cache. We're at the end. So now that we're at the end, we should cache that G is 1. And then we fall back to F. We should see that G is 1 and H is something else. This should work. Echo the cache, you said? I think so. I think I'm in debug mode now. Yeah, we're getting minus numbers. Does it work on the example input? Now, that's a really good question. Okay, so with the example input going from SVR to FFT, there should be one path. There should be one path. And it should go through AAA. So now we call... Vardum takes a dash V argument for verbose. So if you haven't seen it, that's what you're seeing now. It tells you what type it is, what attributes are set, and the length. Yeah, dude. I'm onto something here, you know what I mean? Look, so this makes sense. There's one path to A, and there's one path to this. So is my answer not that? Is my answer just what we've cached? Wait. Hold on. Wait. Is my... If this works, I think I fundamentally misunderstand something about my own code. The answer is 1. Okay. There are 2 valid paths from SVR to out, but there are 8 total paths. Okay, well, that's not right. Sphere is not even in there. But that's what I would want. Okay. I'm just throwing code at the problem. This isn't right. Oh my god, my total is global. I'm modifying a global variable named total. Oh, that's really funny. All right, so now if I do the real input, I'm still gonna get the wrong answer. We haven't validated the path, but we're just gonna get all the paths. Let's see if this actually works. Let's go ahead and... Oh my god. Wow, okay, so that's all the valid paths. Wow, caching is so beautiful. Oh my god. All right. So that's not all the paths. We need to now look at the valid paths. So we need to check the valid paths. I'm not thinking. When I get a path, we'll get there. We'll get there. When I get a path, if name equals end, echo the path. Okay. And then let's get rid of the other echoes I have. Find path. There we go. Let's get rid of the debugging one. Okay. Why do we only print one path? Oh, because we've cached the values. So as part of our caching, we have to we don't have to do anything. I'm overcomplicating this. Find from SVR to FFT. Which we already have the answer to this. FFT to SVR is that. Out, or DAC to out is that. And then the real input from SVR to FFT is what we have. We need, which way did we go? Server to FFT, FFT to DAC, DAC to out. So we just need this. Do we know that this is going to run in any sort of meaningful time, or do we have to go backwards through it? I mean, it should be faster. We're memorizing paths now. I mean, it's still not the like it's going to get faster, but like, Because all we need is this number, and then we multiply these numbers together. Yeah, true. I don't know how much RAM is taking up. How much RAM it's going to use. Yeah, we'll be fine. Yeah, I got the M1 Max Studio that I'm rocking here, so it's a beefy machine. I got it for like music creation and stuff. So that's our find forward memoize path. We might have to go backward. No, forwards was faster. Forwards was the faster one. Yeah. How long is this going to take? Because, I mean, I don't know of many other ways to make it faster. I agree that something isn't right. You know it isn't right? That's funny. It's probably missed. Yeah, you know what? I probably need to just put the local keyword in there something. Just need to toss the local keyword in there. Caching ourselves seems pointless when we just cache it here. Why are we not just checking the cache at the top? Why are we not doing this? Aren't you missing a $sign on cached? If I am, I will lose my mind. But I don't know what you're referring to. You don't need the $signs if they're in mathematical expression, if that's what you're talking about. This is still going to take some time. Yeah, I could. I like that idea. What is wrong here? If we get to the end, we reply 1. That should be... It's 2 paths, right. Should be 1 path, that's right. Finish with 2. Yeah. There are 2 paths there. Okay, this is right. Bad array subscript. Ah. Would help if I used the name variable, wouldn't it? Guys, I'm a good programmer, I swear, okay? Guys, I'm like really good at programming. You have no idea. I definitely don't make stupid mistakes. The YSAP emote. I mean, I do expect some of these to take a bit. But this seems long. That was half of it? Oh boy. Find path on begin. And we give it an empty path. We don't even really need that path variable. That's just for me to see what's going on here. Name and path. If name equals end, then we're done. End is equal to whatever I give it. Awesome. Total is 0. Local cached equals get the cache at name. Otherwise, we default at 0. If it's greater than 0, the cache is set. So we should increase the total by that. We should return with that. And that's all well and good. So let's not even do this. Let's just bring this down here. If cache is greater than 0, then return cached. And then we return, we're done. We're at the cache value. That's great. Make a connections array, read into the array connections from the map, which is our input, at the name we were given. Awesome. So now we have a array of all the possible connections they make. Total equals 0. Connection num. We're using these variables correctly. For connection, in connections, num equals, we're going to call find path again on the connection this time, which is the name. And then we have the path variable, which is just for us to see. And then when we get the answer, we cache it, We say cache connection equals num, and then total plus equal num. The only thing I can see missing here is this, but I think this is made redundant by the call above it. I'll put it back in there, but I think this is made redundant. And the reply is equal to the total of whatever that is. So it either came from the cache, or it, I guess we could do this. Just not set the cache there and just let the function be responsible for setting the cache. Like, it really doesn't matter. So the fact that everything is 0, it's very interesting. Thinks it's parameter expansion. How old is my version of shell check? Shell check's fine. I always fight with shell check anyways. Let's just take a moment to appreciate this syntax for calling functions and how I can still use the global cache variable. Doesn't seem like it's working, but let's just appreciate that syntax. It really is just so nice. We didn't have that last year. Whatever I have here is stupid. It's a stupid issue. It's a stupid bug. I know it. I've dealt with this enough to just know when it's dumb. We're looking inside out, and out doesn't have anything. Why are we looking inside out? Oh, because that's not the end. Oh my god. Don't know if this fixes the issue, but that is definitely a issue. Still seems like it's taken 8,000 years, though. I mean, hopefully it starts going faster. it should be so much faster than this. How is that an unbound variable? Because there was nothing in the array at that thing? Okay. If the cache is greater than 0. Oh. Yeah. Yeah, how about that? We're not caching when we hit bad ends, dead ends. We weren't caching that, so we had to keep looking. That runs a lot faster. That's what I would expect. GG. Yeah. You don't have to put quotes around it if I'm using the double square bracket notation in Bash. The double square bracket is a keyword, not a built-in. So there are different rules for bracket and double bracket. So if you do type on bracket, you can see it's a shell built in. If I do this, you can see it's a shell keyword. Keywords have different rules about how they're parsed. Oh boy, wow. Silly. I knew it'd be silly. This puzzle took me a lot longer than it should have. But you gotta respect these puzzles. Ha! Wait. Of course it's not right. What am I doing? What am I doing? This isn't the right answer. This isn't the right answer at all. Of course. I'm silly, guys. The answer is this with those other two numbers. We have to go from FFT to server. Let's get the notes. FFT to server. We have to go DAC to out. And we have to go that giant number I had. So this times this times this. That's the answer. I don't know if it'll let me submit right away. I think it will. Five seconds left to wait. This took so much longer than it should have. I don't know why this gave me so much issues, or so many issues. You gotta respect these puzzles. You really have to respect these puzzles, but let's go. We got the right answer. Thank you everyone for believing. Appreciate it. You gotta respect these puzzles, man. You can't, when you're just like, oh, it's gonna be easy, like you still gotta show respect. Like you do. It's the way to do it. GG, GG. Thank you, thank you, thank you. What's this gist you got for me, Narf? Oh yeah, that's cool. Copy it with the username and a colon in it. That's awesome. That's what I actually wanted. Let's see what we got here. Okay, very similar. Very similar. You do exactly what I did with the colon thing. Nice, nice. Nice use of semicolon here. Not sure why you needed that. Nice, nice. Oh yeah, you got the DFS, SVR, 00, echo out. Okay. This is part 2. Okay. If one is out, then out equals... Oh, out is your output there. Okay. Two and 3? I'm so confused about... I'm not confused about this syntax. This is just so interesting. If 2 is set, you want the value of 3. Otherwise... You, like, what? Okay. I didn't know about that. Okay. 2 is if passed. Yeah, gotcha. Gotcha. Okay. That makes sense. Yo, Dark Space, thank you for gifting that sub, dude. That's super nice. That's awesome. I appreciate that. Oh, man. Yo, GG, thank you, Minnie. And then if that's not cash, then you... Okay, I see what's going on here. Cute. Okay, nice. Nice solution. I'm afraid to see where you guys golfed. Oh, this is insane. This is insane. Ha! Grep for a line that starts with this. Tal minus C plus 6? Dude, I don't even know what that does. Is that even, like, portable? This is insane. You guys are insane. Manually chopping up her graph after looking at it in GraphViz and doing some math. That's so funny. That's really funny. Start after 6 chars. I didn't even know that was a thing that existed. That's hilarious. All right, let's do some work here. Now, we still have some time before the next puzzle drops, and I do have day 10 part 2. I do not expect to get an answer in the next, like, hour for it, but we could try it, of course. My solution kept track of the number of nodes below that need DAC and or FFT or neither. The number of nodes below that need DAC and or FFT or neither. Like a node that needs to go through. So like you keep track of a list of all the nodes that have to go through DAC and that have to go through FFT. That's what it sounds like. Piano break? I like the way you think. Who said don't stop believing? There we go. Now I can hear. Let me turn on my desktop audio for you guys, huh? Be nice if you guys could hear it too. Let's do the big camera. Dude, the fact that my shirt just says hog is ridiculous. I can't believe you guys are letting me just wear this. That's wild. Let me go to a different piano. There we go. That one sounds good. All right. Oh. Listen, any bash thing is a one-liner if you, you know, put enough semicolons in it. I DFS down and went back up. All right, I'll pull this up, and then this is the last example we're looking at. And then we will head over to the little piano break. Oh, man, I don't know C++ at all. What is happening in C++ world? Okay, main. Here we go. That's what I wanted. Get input. Okay. Num paths, count paths for part 1. Count paths 2. Okay. So get input and count paths. So get input, I assume, is pretty simple. Read the file and then put it into some sort of data structure. Split it on colons. Yep. And then, okay, I have no idea what in place back is. In place back, put it towards the back of something, I guess. Let's see. The helper 2 function. Let's go in order. Count paths 2. Path at SVR. Count helper 2. Paths next cache. Count plus equal res dot need neither. Ah, okay. So let me go up to your helper 2. Okay. This is how you find if something's in a cache. You have to iterate through it one by one. Am I... Create an object that the vector owns. Okay, interesting. Is DAC equals cur is DAC equals cur is FFT. Okay. Oh, I see. Okay. If you're at the DAC one, then you know DAC, you set this one down to 0, you get rid of it. Okay, so the amount that need neither is the, okay, this is interesting. This is a cool solution. That's an O1 operation? Oh, okay. Wait, I don't understand. This is O of 1? Or are we talking about different things? This is an O of 1 operation? This looks like iterating over cache. That's an if. Oh my god. Yeah, you're right. Thank you. Thank you. My brain just saw the semicolon and I just started like my C brain, my Rust brain kicked in. I was like, okay, iter equals the first thing in the cache, while iter not equal to end. Yeah, I totally read that as a while loop. If init statement, okay, this I don't know C++. I just don't know this language. Dude, this is wild. Okay. I like the solution. This is really clever though. I like the isDAC and isFFT. Weird C++ thing that linters love. Ha. That's funny. All right, well, heck yeah, gamers. Let's do a little piano break, I think. That sounds nice. Hog exterminator. Dude, this shirt sucks, man. I wore it. I went camping with my buddy 2 years ago. I bought this shirt just to wear on one of our camping days just to make him laugh, literally, because it was just so stupid. Like, that was why I got it. Of course, it fits like so comfortably, which is like crazy. But it is hideous. All right, what am I doing? What am I doing? There we go. Yeah, who said don't stop believing? Where is it? Am I transposed? That doesn't sound like middle C. It sounds like a B. There we go. That sounds like C to me, right? I don't have perfect pitch, but I play enough where it's good enough to recognize when something's off. Yeah, that's A minor. Okay. Yeah, it was transposed. That's weird. Don't stop believing. There's not enough room on this keyboard to do it. I hate playing on this. I should just go over to my piano over there and play it. That's what I should actually do. This is the greatest shirt I've ever seen. This shirt sucks, man. It just says hog. I wish Eric was here to get upset that you can hear my mic sounds too. I'm telling you guys a story like I'm not muted. Can you believe that? I'm awesome. I'm so smart. In before you guys say I was muted. I was actually at a wedding like 15 years ago, and the sound was having issues, but they had a piano there, so I actually went up there and played Pocketball's Canon. I could play it way better than how I was doing it there, but yeah, I actually like went there and played piano, which was pretty crazy. Like everyone was like, "Didn't you feel the pressure?" I was like, "Luckily I didn't, man. I was just younger and confident, and I just did it." So like, yeah, it was awesome. They should have paid you. Listen, I agree. Do you happen to know Sadie's, I can't pronounce that word, number one? I have no idea what that is. I assume it's a song, but I don't know it. I might know it if I hear it, but I don't know it. You joke about the copyright thing, but like, I'm working on my Bash course. I said it earlier in the stream, last night I exported the final video. I put quotes around it because there was an error with it, so I have to go re-export a new one once I swap out some things. There were some typos. Long story short, I exported it and actually did upload it to YouTube just to make sure it cleared copyright, and it does flag one of the songs in it because I put my own music in it. So like, I'm using my own music and it's like flagging copyright. I'm like, dude, this is just wild. Do you even know who Sadie is? I have no idea who that is. Is it like someone famous? Should I look it up? Should I know who it is? Uber spamming every YouTuber I watch? Dude, that sucks, man. Eric, Sadie, like, you guys can say whatever names you want. I have no idea who you're talking about. I could look it up, I suppose. Can you imagine? Of course, I'd have to turn off the desktop audio because I don't want to get flagged for copyright. I know people have been saying like YouTube's AI system is like taking down channels left and right. Nope, I'm looking up this one song, Eric Sadie, whatever, #1. I've never heard this in my life. It's nice, it's cool, but I don't know it. Oh. All right, let's lock in here. We have about an hour till the next puzzle drops. Which means, let's see. We should probably look at the next one. Right now, I remember why I was watching on YouTube before. Just got 2 minutes of ads. That's brutal. Yeah, dude, I can't deal with these ads. They're so annoying. Twitch just runs them. Tells me there's an ad in progress, but I don't know when people are going to get ads. It's so lame. I prefer watching on YouTube. I'm not a Twitch guy. I like watching on YouTube, so... All right, let's lock in. Okay. Do you guys remember this puzzle? We got part 1, but we did not get part 2. It's about those machines and their joltages. I know you can't see my terminal, don't worry. Yo, Narf, gifting a sub. You guys are so nice. Thank you. That's so awesome. YouTube rules, dude. I agree. I really like YouTube's been really good to me. Heck yeah. Thank you, Narf. That's so cool. So there's a stupid joltage problem, and I asked for no spoilers and no hints, but of course people just say things. I'm not upset with anyone, like I'm not mad, but like it's been spoiled to me that this is a linear algebra problem and it uses something called Gaussian elimination. I don't know what Gaussian elimination is, and I was terrible at whatever math. So I don't plan on looking up solutions. I don't care if I know the algorithm names because I wouldn't be able to implement them. I'm going to see if we can program and memoize and cache and brute force our way through this. That's my plan. Bad Cop, I think, did the math solution, which probably meant like looking up really hardcore math stuff, which is awesome. But I'm going to see if we can do the programmer brute force solution. So that's my attempt. I've been working on day 10, part 2 for 2 days straight now. Yeah, dude. I don't know, man. We're going to be screwed on this. I solved part 1 entirely with bitwise operations. I felt pretty smart about it. Then I read part 2. Hey, Quote Pilgrim, you and I the same. I did part 1 by turning them into that and then XORing them together. So, yep. Now, I do have some solution. I do have some ideas for this problem. Yeah. So, I had to abandon C++ part 2. See, that's the thing. I don't want to abandon Bash for this. I know Bad Cop was able to get it working. I think she like had to look up the math for linear algebra. I should go watch her VOD, which is cool. That's awesome. I'm glad Bash can do it. But like, I want to do this like a programmer. Like, when I say like a programmer, it's not a value judgment. I mean, like I want to throw Bash at the problem and see if we can get it. So I have some ideas here. So if you remember this problem, we can ignore these lights over here. We have these buttons. So this problem has 6 different buttons. And when you click a button, it increments an integer over here. So our final state that we want is 3, 5, 4, 7. And we start with state 0, 0, 0, 0. So if we click this one, we'll now have state 1, 1, 0, 0. And we have to get up to this. Now I've done some thinking. Like I said, I don't solve these problems off stream, but my brain's chewing on these subconsciously. I have a lot of thoughts. So let's go look at one of the real examples because they are gnarly to reason about. So if we had -1, the real input, we can see this one here. We have to get to this state. So that means there are what? 7 indices of this array. And there are 1, 2, 3, 4, 5, 6, 7, 8. 8 buttons and 7 indices. This is gigantic. So yeah. The reasoning I have done about this, the thinking I have done is obviously we implement some sort of breadth first search and we try every possible combination of buttons. It's not feasible. It's just not going to work. I could write this in Rust on the fastest computer and it's not going to work. So we have to find some way to make things more efficient. And I think the first thing I want to try and do is take this and reduce it, lower this down. Because getting to this is very difficult. But if we could get down to like, instead of 37, get down to like 17 or get down to whatever, find some sort of algorithm to lower that number and lower the like possible ways of doing it. I don't know what this looks like, but that's what I'm envisioning here. Now, there is something I noticed here. I have to think about this. I thought about a bunch of the stuff yesterday and I kind of lost track of it. Here we go. I was thinking about the something. I was thinking about something. All right, give me a second. Let my brain catch up. Dave, dude, I do this a lot. It's crazy how often I do this. I catch myself doing this. It's just how I think. So here, I will show you my thought process from last night, okay? But okay, now I remember. I need to get some props. Now bear with me. You're going to find out this background is not actually green screened and it's actually just legitimately a real place that I can walk to. Oh, hey. Got a donut here. Got a nice little Dunkin' Donut. Hey-o. All right. So here, yeah, the corkboard with the pins and strings. Here's what I'm thinking about, okay? Now bear with me. Here's a Rubik's Cube, right? All right, I'm a nerd. I like Rubik's Cubes. I think they're fun. Here's a 3x3 Rubik's Cube, okay? Once you solve the 3x3, the next problem is to go up to the 4x4, right? Naturally, once you can do 3, you can do 4. And then once you can do 4, the next natural thing is to go up to the 5x5 cube. I'm a nerd. I don't know if you guys know this. So why am I bringing this up? Because you would think that if you could solve a 3x3, the next one you should go to is a 4x4, but that is not true. It would actually be easier for you to learn how to solve a 5x5. So how fast can you solve a 3x3? My PB is 49 seconds. My PB is 29. Now, my PB is 29 from like 20 years ago. I don't think I could solve it that fast. Unpracticed, probably a minute and a half. I would say about a minute and a half. So yes, Narf understands. So you would think that you would want to go to the 4x4, but in reality, the 5x5 is easier. And the next one after that is the 7x7, not the 6x6, the 7x7. Technically 7x7x7 because it's 3-dimensional. But the next one you would want is the 7x7x7. So when I said I'm a nerd, I meant that I'm a nerd. Yes, because the 5x5 is basically 2 3x3s. Yes, yes. So Narf, you probably know this. What's fun about the 4x4? What's really fun about the 4x4 that I like is you can get into some impossible states. Now, they're not really impossible. Obviously, you can solve them. But the 4x4 can get itself into what looks like situations that the 3x3 cannot. So what that means is if I have a 3x3 here and it's perfectly solved, if I grab this edge piece, this piece that's connected to 2 different colors, if I grab this and flip it, like just pull it out of the cube and put it back in wrong, the cube is unsolvable. The cube becomes unsolvable. So when you have a 4x4, you can get in that situation where one of the edges is flipped, but there's 2 edges. There's 2 edges. So you can get into these weird parity situations where you have to flip the edges. So the 4x4 can get itself into situations the 3x3 really can't, but the 4x4 can work its way out of those situations with the right algorithms. So I was cooking when I was thinking this, okay? I don't know if I'm gonna come up with a solution with this, but I was thinking about this because the parity is what's important here. Let's look at these numbers. Do you notice something interesting about these numbers? 17, 14, 84, 71, 44. There's nothing interesting about them per se. But 17, how do we do that? We have to click a button, any button, it could be any button that affects the 0th indice. We have to click that button 17 times. That means at the end of that, remember these states over here? Technically speaking, the LED will be on. It doesn't matter that the LED is on or off. We don't care about the LEDs for this problem, but think about it. I was thinking about this. 17 means that it's on, whereas 14 means that it's off. Because 17 is odd, meaning it's an odd number of button presses. If the light starts off and you hit it an odd number of times, the light will be on because you've toggled it 16 times. So you've toggled it 8 times and then you had one final press. 8 toggles and one final press. In this one, you've toggled the light 7 times with no final press. So what can I do with this information? I have no idea yet. But look at it this way. If we just take is even, is odd, right? So basically we're modulating, we're doing a mod 2, right? We're basically doing a mod 2 here. I don't know if this makes sense. Let me line these up because I might just be crazy. Like I feel like I'm Charlie Day with the cork board. Like, but I was thinking about Rubik's Cubes. I don't know if this works, but look at this. So this is if we do a mod 2. What does this tell us? At the end of it, this light will be on, and this light will be on, and this light will be on. We don't care that the lights are on or off. We don't care. We don't care that the lights are on or off. The point is, in order to achieve the final state, a button that affects this index has to be pushed an even number of times. Okay? So this means that this button required 7 repetitions. So if there's like something that affects that button, you'd have to hit it and then undo it because the repetitions when it comes to the final state are almost free. Because when it comes to these 2 things, I can flip these 2 edges. That's great. But in a 3x3, I can't flip that edge. That edge is stuck. I have to pull it off of the actual cube. So with this situation, in order to get to this final state of 17, I have to hit it one last time. after I've done all my presses that may or may not be repetitious, but I've like repeatedly turned the light on and off first. So I think we might be onto something, because here's what I could do. I can solve this problem. And I believe there might, I don't know this yet. I don't know this is true, but there may have to be a solution. So remember part 1? If we treat this like part 1, here's what the lights we're trying to solve for. Instead of solving for these, we're solving for this. So I think we could just fabricate our own input and pipe it into the part 1 solver. We have a working part 1 solver. So pound sign is on, off, on. That's what the layout looks like. And then copy all this stuff and put it into here and pipe that into the part 1 solver. And I don't remember how I did part 1. Oh, we did a forking solution. Did we print out anything? We had totals.txt. Let me relook at my part 1 code. Yeah, these printed out their totals to something. Let's go ahead and RM totals. So we have 3. What does part 1 solve? Is that how many puzzle things? Oh, this is the fewest number of presses, right? Yeah, I remember you saying no one asked me how this works. Dude, true. So here's the thing. It takes 3 presses. The optimal path is 3 presses to get to this state. We have to get to this state. We have to get to this state to get this final thing because of where the odd numbers are, because we can only increment by 1. If you think of this top as like a jagged edge, in order to make those little jaggies at the top, we have to get to this state from a blank state somehow. I think that's right. I don't think there's any other way to do it. We have to be able to go from a blank state to this. And in order to do that, it takes 3 button presses to get there. Cool. We can figure out what that exactly looks like by modifying part 1 slightly. And then when we get there, we're just free to press whatever buttons we want as long as we undo them. Doesn't mean we have to hit the same button twice. But for every index we turn on once, like 24 here, for example, we also have to turn it off. If we wanted to get to, let's say 36, because this is like, let's assume it's just 1 less, we have to hit whatever button hits it. We have to hit it again. We have to do that 13 or whatever, 36 divided by 2, 18 times. I don't know how to make sense of any of this information, but this is my current thought process. I think this donut's any good. Oh, yeah. Original glazed donut. Incredible. So, we have to figure out how to make this do something meaningful. So I'm going to take a little break and eat my donut, and I'm going to think about these numbers. But this is my best guess so far as to how this solve this, like, not like a math guy and more like a programmer. Protein cake sounds pretty good. Okay, I guess you're right. It is pretty mathy. That's true. These puzzles have made me more mathy. They really have. Now, of course, it takes 3 button presses to get to this LED state. So we should look at what those button presses are. We should have it print those buttons out. All the possible ways to get there in 3, that is. Because, this LED might have been turned on, off, on. We don't actually know. We just know its final state. So we'll have to figure that out. And then we'll be able to subtract that integer from the joltage total. And that'll give us to all even numbers across the board. Then, we're trying to reduce it. Then we can figure out how to further reduce it. Maybe we could divide it by some sort of greatest common divisor. I don't know. But there might be something here. And at this point, I don't care if I get a generic solution. I just want to be able to solve my own puzzle. So if I have to do some manual work, hey, I'm for it. But also, we will get preempted in 45 minutes because I do want to look at the new puzzle when it drops. And I'll see if Bad Cop's up for that too. I'm not certain you get any useful info. Man, if that doesn't sum up how I feel about this. That's it. Oh yeah. Don't worry, I'm not discouraged. This is my best chance, dude. I gotta play with the numbers because my other alternative is to breadth first search, and it's not gonna work unless we start really aggressively short circuiting the branches. And we have to figure out how to do that. So maybe there's some sort of heuristic, but I don't have any good leads now. This is the only lead I could really think of. So let's go ahead and CP part 1 to possible, I don't know, we'll call it something. Yo, thank you for the super chat. That's super nice. It's 1:16 in Chile and tomorrow and busy, so bye. Yo, appreciate it so much. Thank you for the super chat. I have no idea the currency or what 2,200 is in that, but thank you for that. I appreciate it. I think that's super nice. That's awesome. You guys don't have to donate if you're watching. If you do throw bits or super chats, I of course appreciate it, but no one should feel like they have to do that. So just enjoy the content. It's free. I'm thinking about maybe the mods course could be a heuristic for a BFS. I've been thinking that too, because we can go through and we can start modding it by different numbers and get something out of it. Something, you know what I mean? Something. I don't know what that something is, but there's something here. Just call it get buttons. Stupid name, but you know, here we are. Let's do that echo and let's pipe that into get buttons. Let's not do the forking solution because that's just super annoying. Well, the forking solution is actually fine. We run find solution and find solution returns the number that was pressed. My DFS that had a ton of optimization, I let it run after my computer while I was at work and solved 40 of them. Oh my god, that's hilarious, actually. That's awesome. I don't remember what half these variables are. I have a variable called pad that I don't use. Awesome. Awesome. Go, Dave. So instead of storing the number, we just have to store all the buttons we pressed to get to this point. I was doing things like only pressing the buttons 0 to the max they could be pressed, min of any joltage, yeah. In order from left to right, etc. Still not enough. Oh boy. Yeah, this is a tough problem, but I don't want to believe that I need like a math degree. Not that you need a math degree to do linear algebra, but you know what I mean. I want to believe that this is solvable this way. Yeah, I don't think you need linear. Yeah. They taught me the Gaussian elimination stuff in high school honors math. They may have taught me that in high school, to be honest, because I was in honors math as well, but it's so long ago, and I, like, none of that stuff's in there, man. That's just all gone. How do we do this? We just check if we had anything cached, then we don't bother. Otherwise, if it's the desired one, then we got a match, so we just return it. We return the number pressed. Otherwise, we try going into that button. Okay. So instead of return press, we should return path and button. What am I doing? Why am I overcomplicating this? Get the button. Try to do that. If we've already seen it, awesome, we're done. Otherwise, if it's desired, then we got this. Then we should just return path button. Otherwise, we push path button, and then we cache 1. Okay. Okay, well, we got something there. That can't be right. That could be right. The issue with the linear is the system of equations are purposely not easy to solve with normal methods. Okay. Yeah. Yeah, like right now, I'm not giving it my full total thing. But according to this, it's leading me to believe that in order to... Hold on. I think I'm storing the wrong data. That's the button you pressed. I'm just confusing myself on what this function actually does. Yeah, I definitely need more time to think about this. If we got here, then we return the path, comma, the button. We always append the button to the path. What is the button? The animation on the Wikipedia page for causing elimination to show I forgot what it was called. Matrix simplification was enough to remind me how it worked. Oh, nice. When in Purdue in the CS in the early 70s, it was all heavy math and calculus using COBOL, base. Oh, wow. Fortran, assembly. But over the years, I found programming is just logical data manipulation. Yeah, it definitely seems that way. Way less focus on the math. What are these numbers? What is button 89? Oh. Oh, these are, what is button 89? That's, I can't think. Those are the buttons in binary. These are the buttons in binary that you have to push. So, if we do, is there an easy way to convert this from binary? I shouldn't have been using binary. I just overcomplicated it for myself. How do we turn something? I think I have a 2 binary function. The num and a pad. I don't know how much to pad it by. Okay. Hope they're in the right order. Oh, no, there's 7 buttons. There's 7 buttons. I should be padding it by 7. Okay, there's the input. Those are the buttons we have to push. So let's go ahead and do 2 binary of 46, pad it to 7 buttons. Do a 53, pad it to 7 buttons, and 94, pad it to 7 buttons. So it wants me to hit this button first, which would be 1, 2, 3, 5. It could be backwards. If it's backwards, then it's button 2, 4, 5, 6. Or it's the secret third option, where it's none of these things, and I don't remember what I'm doing here. 0 index backwards? No way. 0. Oh my god, you're right. 1, 3, 4, 5. Wow. 1, 3, 4, 5. Okay, so hit that button once, then hit 1, 2, 4, 6. And then hit 0, 3, 4, 5, 6. Or 0, 2, 3, 4, 5. Okay, so you literally hit this button, then this button, then this button. And if you hit those buttons, we'll get the light that we wanted, which was not this. We get this light. If we hit those buttons in that order, we get this light. It's actually base 64 and you're getting really unlucky. So let's go ahead and change that to binary function, which I don't think we're using it anywhere. Yeah, doing it backwards. So we're doing the plus equal here. Plus equal puts it at the end. So instead, we want it at the beginning. And then to pad it, we want to pad the beginning. It is right for binary. You're right. Like that is right. I just didn't like reading it that way. So I probably should have called this like 2 binary. I probably should have just reversed the string. Probably should have just reversed the string. I don't know. Yeah, I'm not in a good mindset to actually make headway on this. Oh my god. There we go. So 0, 2, 3, 4. Wait. 1, 3, 4, 5. There we go. So this button, and then 1, 2, 4, 6. The next button, the button next to it, and then 0, 2, 3, 4, 5. Okay, so literally this button, this button, this button. If I hit those buttons, then we will end up with the light of this. So first character of Shaw, one of your real input is 4. Get out of here. Oh my god, Dark Space Jr. over there. So 0, 1, 4, 6, 1, 3, 4, 5. Okay. So this one's 1, 3, 4, 5. We hit that one first. I mean, it doesn't matter what order you hit them in, I guess. So we hit 1, 3, 1, 3, 4. We toggle the 4th bit, but now we have to turn off 3, 5, 1. So there's a 1 here, a 3 here, and a 5, 1. So we turn those bits off. And then we have a 4 again, which means we have to hit a 4 again. Okay, let's make this easier. These are the buttons we have to hit. Oh boy. These are the buttons we have to hit. Doesn't matter what order we hit them in. And if we hit the buttons, if we hit those 3 buttons, we will turn this into this. So if we hit this button, then we end up with dot on, dot on, dot. Okay. And then if we hit this button, we end up with dot again because nothing happens, dot because we've turned off array spot 1, light on because we've turned on array spot 2, 4, so we 3 is still on, we turn 4 off, we leave 5 on, and we turn 6 on. And then we go down here, and this should do this. This should give us the same thing. So if we do the same calculation here, this is this, and the 1 stays off, the 2 gets turned off, the 3 was on. No, wait. 0, 1, 2, 3. I'm confusing myself, but this should work out. This is 1, 3, 4, 5. Okay. Oh, this one's wrong. No, this one's right. No, we pressed 1, so we turn it off. 2 gets turned on. 3 stays on. 4 gets turned off. 5 should be on. And then we go down here. So we press the 0 button. So 0 should turn on. Array spot 1 was off, so it'll stay off. Array spot 2 was on, but we pressed the button, so it turns off. Array spot 3 was on, and we pressed the button, so it should turn off. Array spot 4 was off, so it turns on. Array spot 5 was on, so it turns off, and array spot 6 falls through, so it's on. Okay, yeah, this just should all work. This was just so overly complicated. But basically, those are the buttons to turn this into looking like how the lights look. So with those 3 buttons pressed in the most optimal way possible, we press those 3 buttons, we end up with all of the numbers being even. So we started here, and then we're going to make some changes. So we've modified the 0 index once. So we decrement. We're going to decrement instead of going up. Think about it. We're taking it away. The 1 index we modified twice, so it's still even, but now we're down to 22. The 2nd index we've pressed twice, so we subtract from it twice. The 3rd index we did it twice, so we subtract from it twice. The 4th index, we did it 3 times. Is that right? Zero, 1, 2, 3, 4. We did it 3 times. Wait, how is that possible then? That doesn't give us an even number. Wait, we were just optimizing to turn the lights on. Oh no. 1, 2, 3, 71. Goes down to 69. Yes, this one's not even either. 44, spot 4, 1, 2, 3, goes down to 41. Okay. No, I think our goal was, no. I'm confusing myself. I wanted to get rid of the parity. Oh, maybe I just repeat it? That wouldn't work. It might work. Yeah. Yo, Narf, have a good one. Yeah. And good luck. Good luck on the final puzzle. 41. And then 32 is the second to last one, which is 5. We've pressed it twice, so it goes down to 30. And 6, we've pressed once, which goes down to 70. Okay, so we still have some even numbers there. So we went from that to that. If we do that again, it's not, well, no, if we do it again, it's not necessarily the most optimal. Why would I think that? Okay, I'm not going to get this puzzle done in 20 minutes. This isn't right. Maybe my button algorithm's wrong. My buttons might just be wrong. Wait. We press erase spot 0, which turns it off. We don't do anything to erase spot 1, so it falls through. We press 2, 3, 4, 5, which turns them all off. And then we let that one fall through. So yes, this works. Okay, so we start at this. We run these button presses, which gets us to the ... state. So this is in the ... state, where all the lights are off. Meaning that how's this working? We start at this. Then we subtract from the 0th index once. We subtract from the 1th index twice. The 2nd index twice. The 3rd index, subtract from once. The 4th index we subtract from twice. Yeah, no, this is, yeah, okay. I think I was doing something wrong here. Let's just make a new one. So if we get down here after doing all that, we've toggled the 0th state once, bringing us down to 36. We've toggled the 1th state twice, bringing us to 22. We've toggled the 2nd state twice, bringing us to 82. We've toggled the 3rd state twice, bringing us down to 69. Yeah, wait, how is that possible then? Oh! Because they don't have to start at the 0th lights. Okay, yeah, no, I'm making a bad assumption here. I'm enforcing that they start at this. Oh, I see what I'm doing. Oh, I see what I'm doing. Okay. There's no guarantee that it gets down to that space at that state. I'm enforcing a fake starting state. Oh, okay. I get what I'm doing. I'm making my own new starting base state. This is crazy. Bear with me. I think I've lost a lot of people. We're assuming that we're starting at a base state of this, and we're trying to get to a base state to match the thing down here if we treat them all as even and odds. Yeah, so if we even and oddify this number, this is what we want. Okay, so we're coming up with our own base state. So we're saying this is what we're given, so assume the ending state looks like this. how do we go to a blank slate state? We do these operations. And if we do these operations, we get to the blank slate state. And after we get down to that state, our final solution looks like 36, 22, 82, 69. 44 is array spot 5, so 1, 2. So that becomes, 44 becomes 42. 32 is array spot 5. Wait. 32 is array spot. Oh, there's 0 index. Wow, I am just, that's not working. 0, 1, 2, 3, 4. How many 4s show up here? 1, 2, 3. That brings us down to 41. 32 is 5. How many 5s show up there? 1, 2. That brings us down to 30. 71. How many 6s show up? 1. 70. Okay. So this state now is our blank LED no light state. No, wait, then why are we enforcing this? Oh man, dude, I'm not, this puzzle's gonna destroy me. Maybe we subtract them? We're just playing with numbers at this point. Are you assuming only those 3 buttons are involved in getting to the joltages? No, I'm not. I can't explain what I'm thinking because I'm not actually thinking anything coherent anymore. I had something, but I'm not. I'm losing it. Playing with the numbers worked for one of the problems last year. It did. It 100% did. That's why I believe that it's possible here. I want to believe that it's possible. Yo, what up, Ash? How you doing? Welcome, welcome. I know most people have thrown a solver at this one. That's so boring to me. It's so boring to me. I don't want to do that. I want to be able to, from nothing, derive an answer for this. Even if it's slow, I don't care. Yep, catching up on puzzles. So, oh, I gotta change the title of my stream. We knocked out day 11. Here, I'll show you, actually. Because I could use a break from this. We are just missing part 2 of day 10. People in the chat can back me up here. I would say this is probably the hardest part. Part 2 of day 9 was very hard, but part 2 of day 10 is like impossible if I don't throw linear algebra at it. Not necessarily impossible, but you know. So what was I doing here? I don't believe this. Yeah, the standard, if you're just doing the standard lib only, it's gonna be tough. I thought I was onto something, but something's not working out how I planned it to work out. But my solver might be wrong. There is a possibility of that. I mean, we tested it and it works. Given these joltages, we can press this button, and this button, and bring us back to the ... state. But shouldn't the ... state be everything is even? I'm not... Okay. Okay. Now we're going to press this button. This falls through, this turns off, this turns on, this stays on, this turns on, this stays on, this turns off. Okay. Now we're going to press this button. Okay, so we press the button, so this turns off, this stays off, this turns off, this turns off, this turns off, this turns off, this stays off. Okay, so this gets us to the 0 state. We started with these joltages. Wait. Am I just wrong here? What? This should be this. Oh, I just had my things wrong. Yeah, wait, I'm just wrong. I'm just wrong. I'm just wrong. Yeah, I just solved for the wrong thing. So I'm just stupid. Good. Yes. Okay. There's so much work involved with this. Okay. Yeah, I just had the buttons wrong. Like this should be 0, 1. So I can't do this right now, but this will work. Yeah, my buttons were just wrong. That makes me feel a lot better. Okay. So now if we do this, now we have this number and we press the buttons. So this turns off because we press the button. This turns on because we press the button. This stays off. This stays on. This turns on. This doesn't do anything. And this turns off. Okay. Now we press these buttons and that falls through. That turns off. This turns on. This stays on. this turns off, this turns off, this turns on. Okay. And now, yeah, so now we're left with the blank state down here. Awesome. So now when we start doing our work here, we can get a list of the button presses here. So that was a 1 press here. That was 2 presses here, 2 presses here, 1 press here, 2 press here, 0 press here, and 3 presses here. So now if we take the difference, we'll get all even numbers. 36, 22, 82. These need to not be spaced. Okay. 70, 42, 32. Look at that. I'm doing matrix multiplication. Matrix math. 68. Okay. Perfect. That is what we can do. I don't know if this helps us, but we can find the number of buttons to, as quickly as possible, get us to an all even number state. When we are an all even number state, then every button we press, we have to press again to turn on and then off. Now that we are all at an all even state, we might be able to figure out like the most optimal way to subtract the most number of digits from this using the most buttons and get like a very repetitive way of doing it. So like if I can decrement all of them at the time, we might be able to start paring this down. We might even be able to do some like math. We might be able to find the greatest common divisor of all these. I don't know, but we got somewhere. I'm going to save that work and we will come back to it because we have to get ready for day 12 because day 12 drops in 8 minutes. So gotta lock in for that. I'm gonna message Bad Cop. Yeah, we'll see what Bad Cop says. All right, I messaged her. I'm gonna go grab something to drink. I'll be right back. Yo, what up, gamers? Dark Space, I don't actually know. Are all day 2s like that? Because I remember last year I encountered that. If that's the same for this year, then there's a very good chance that Bad Cop beats me in part 2. Okay, fair enough. I don't know if Bad Cop's ever actually finished an Advent of Code, to be honest. So I wonder if, I don't know if she knows that. So like, yeah, just so you know, I don't know. She might, but I don't know if Bad Cop knows that. She might, though. I love the animation on the the website here. Like, it's so cool. The blinking lights and stuff. It's really neat. Dave, you ever visit Texas? Want to be my +1 to gamer anime soundtrack concerts? Listen, I've never been to Texas, but I'll hit you up with a solid maybe on that one. Because it actually sounds kind of fun. Keyboard? I'm using the Mac keyboard, whatever this is. The wireless Mac like Magic keyboard, I think it's called. I'm not super picky about keyboards. Death Stranding or Attack on Titan? I don't know either of those things. Yeah, personally, like, I'd definitely be more inclined towards video games than anime. I'm not much of an anime guy. I've seen a couple that I enjoy. Oh no, I'm not down for Broadway shows. I appreciate it so much. That's such a nice offer. I cannot stand Broadway shows, dude. I hate Broadway shows. I hate musicals. More power to you if you like them. I don't judge. They're just not for me. Dude, that's a smart idea, getting a math major brother to do it for you. So, yeah, that's very, very smart. That's true. That's true. Ash, I'll talk to you after this stream, because I also know Warforged in real life, and I think those two people know each other, but I don't want to say anything while I'm on stream. But yeah. What VST are you using? This is through Logic Pro. I'm using Native Instruments. Actually, I don't know if it's Native Instruments or not. Noir. Noire piano plugin. I forget who the maker of it is. Just Noir. And I've customized a lot of parts of it. Well, we have 34 seconds and Bad Cop has not gotten back to me, so I'm going to assume no. Does anyone know if Bad Cop's streaming right now? She's not. So, we have 20 seconds. Can I change my title in 20 seconds? Day 12 in Bash. Oh yeah, Bad Cop's probably fine. All right, day 12 is unlocked. Let's go. We're not racing, so let's have a nice little relaxing evening. Christmas Tree Farm. You're almost out of time, but there can't be much left to decorate. Although there are no stairs, elevators, escalators, tunnels, chutes, teleporters, fire poles, or conduits here that would take you deeper into the North Pole base, there is a ventilation duct. You jump in. That's right. After bumping around for a few minutes, you emerge into a large, well-lit cavern full of Christmas trees. There are a few elves here frantically decorating before the deadline. They think they'll be able to finish most of the work, but the one thing they're worried about is the presents for all the young elves that live here at the North Pole. It's an ancient tradition to put the presents under the trees, but the elves are worried they won't fit. The presents come in a few standard but very weird shapes. The shapes and the regions into which they need to fit are all measured in standard units. To be aesthetically pleasing, the presents need to be placed into the regions in a way that follows a standardized two-dimensional unit grid. You also can't stack presents. Okay. The presents come in a few standard but very weird shapes. Tetris. The shapes and regions into which they need to fit are all measured in standard units. To be aesthetically pleasing, the presents need to be placed in the regions that follows the standard. Did I just read this out loud? See, this is what happens. I become a content creator. I'm not even parsing what I'm reading. Yeah. As always, the elves have a summary of the situation, your puzzle input for you. First, it contains a list of the present shapes. Second, it contains the size of the region under each tree and a list of the number of presents, each shape that need to fit into that region. For example, oh boy. Okay. We'll have to think about this because I'm not really grokking what's going on here. The first section lists the standard present shapes. For convenience, each shape starts with its index, a colon, then the shape is displayed visually where pound sign is part of the shape and dot is not. Okay, that's fair. So you keep reading here, and then you go down here to the different sizes. Awesome. That's how I felt when you read every puzzle out loud. Dude, yeah, some of it just doesn't get through, man. Let's see. Okay. The first section lists the standard... I see, I'm already doing it again. The second section lists the regions under the trees. Each line starts with the width and length of the region. 12 by 5 means it's 12 units wide by 5 units long. The rest of the line describes the presents that need to fit into the region by listing quantity of each shape of present. 101032 means you need to fit one present with shape index 0, no presents with shape index 1, one present with shape index 2, no presents with shape index 3, 3 presents with shape index 4, and 2 presents with shape index 5. Nice job, Eric, alternating between like numbers and actually written out numbers. Like, it's very easy to read these puzzles. Presents can be rotated and flipped as necessary. Oh, God. To make them fit in the available space, but they have to always be placed perfectly on the grid. Oh, hey, Eric's here. Nice. Welcome. Oh, my God. I'm glad you could join us. How many streams do you have open when these puzzles launch? I'm very curious. But yeah, no, these puzzles are like, they're super easy to read through. Like, I appreciate when you use numbers, like when you represent things numerically, like you're very consistent. It's really good. 1 to 3 streams of it. Nice. That's awesome. That's awesome. Is Eric the puzzle man? Yes, Eric is the puzzle man. He's chilling in my Twitch chat right now. Okay. This does feel like Tetris. This is awesome. Presents can be rotated and flipped. Oof. But they have to always be placed on the grid. Shapes can't overlap. That is, the pound sign part from 2 different presents can't go in the same place on the grid. But they can fit together. Oh my God. Okay. I see. The elves need to... This reminds me of that ram falling puzzle from last year. Oh, Eric, people in the YouTube chat are saying, thank you for the awesome yearly challenges. The first region is 4x4. In it, you need to determine whether you can fit 2 presents that have the shape index 4. After some experimentation, it turns out that you can fit both presents in this region. Here is one way to do it. Okay, cool. Yes, that makes perfect sense. Yes, that makes sense. Eric says, hello, YouTube chat. You're very welcome. The second region, 12 by 5, is 12 units wide, 5 units long. In that region, you need to try and fit one present with index 0, one present with index 2. Yep. Turns out these presents can all fit in the region. Here is one way to do it. You know what this reminds me of? It reminds me of that stupid picture where it's like, this is the most optimal way to cram 17 boxes into a place. Like, I know they're not like axis aligned, but still, that's what it reminds me of. Here's one way to do it again, using different capital letters to represent all the required presents. Okay, the third region's 12 by 5. It's the same size as the previous region. The only difference is the region needs to fit one additional present with the shape index 4. Unfortunately, no matter how hard you try, there's no way to fit all the presents in this region. So this example, 2 regions can fit all their listed presents. Consider the regions beneath each tree and the presents the elves would like to fit. How many of the regions can fit all the presents? Oh, wow. Okay. This is cool. Let's go ahead and start doing some bookkeeping over here. We got day 12. Also, Eric, I am all caught up except for day 10, part 2. I have a lead on how I want to solve it. I unfortunately had a little bit of it spoiled in some of the approaches people took, but luckily I don't know what any of the words mean, so I'm still going to approach it as less of a math guy and more like a programmer. So I am determined to find a solution. I don't know if you were here earlier. I brought out the Rubik's Cubes to start talking about my thought process when it comes to solving it. So, yeah. Everything except 10 part 2 is a popular amount of progress tab. Sounds about right. Oh, man. Let's see. Let's do this. All right. Sample input.txt. I know you can't see my screen. I'm just copying over puzzle data right now. Real input.txt. Oh my God. Okay. That's a lot of real input. Okay. Cool. Oh, I was sharing my Safari during that. Whoopsies. But luckily I didn't scroll down all the way. WTF, does flipping something look like in code? Shouldn't be the worst thing in the world to flip something. If you can flip it vertically or you can flip it horizontally, you just read one array backwards and write it back into an array. I mean, this is fun if you ever made like, photo editing software. You have to like learn how to rotate something or flip something. It's a fun little puzzle. You're just translating an array effectively. Now in Bash, where we don't have two-dimensional arrays, I don't know why I do this to myself. All right, lock in. Cool. So there are 33 lines in the example input, and there are 1,030 lines in the real input. So this is going to be a lot of fun. Part 1. User bin env bash chmod plus x. Part 1. Now we should have to work on just reading the we have to read the puzzle data in. So we should get a index, a colon, then the present data, and then a space. And if there's an X in the line, then we are on to the next move of it. So fun little puzzle. Spoken like someone who hasn't been traumatized by Nessie. 2020 day 20. No, I have not. I have not. So I'm excited for that. I have decided though that once all this is said and done, I will be picking up streams. Probably not as regularly as I'm streaming, but I will be doing streams in the future. And we're going to start with 2015. And we're going to do Advent to Code one day at a time. So we're going to crush it. It's going to be a lot of fun. Let's start puzzling this. While... yeah, we're not even going to separate in colons. We're just going to read this like this. Is there a hacky way to get a nested array in Bash, or is it straight up impossible? Oh, it's impossible. There's ways to, like, you literally can't do it, but there's ways to emulate it by using a key value store. Bash kind of has hash maps in a way. So, let's see. Should we use Eric's favorite thing and just use regex? That kind of sounds fun, doesn't it? Yeah, let's do that. Index regex starts with 0 through 9 plus colon end of line. We'll see how good I am at regex on the spot. And then the dimensions regex starts with a 0 through 9 plus a x, and then a 0 through 9 plus, I know I need parentheses around it, plus, and then a colon, and then the data, but we're not going to get it as an array. We're just going to get it as string data. So dot star end of line. Let's go ahead and put these in capture group so we can actually get the data we want out of them. There we go. So now we should put ourselves in a little bit of a state machine, but we'll worry about that when we get to it. Reading the line, if line regex match the IDX regex, then new present time. So present index is that. We'll say present index is bash rematch of the first capture group. So now we have that, and we can just continue on to the next line. State equals present. Let's make this a little bit of a state machine. Okay. Elif, the line matches the Ohio is a state. That's so good, Ash. I'm so proud of you. That's really good. That's really good that you know that. All right. Dimensions regex. So if it matches the dimension regex, then we have everything we need. So let's go ahead and actually start storing some of this data. We need to have a... God, storing the presence is going to be a nightmare. Let's do this. I'm thinking. Let's not do this, actually. But we can't unpeak a line, and we don't know how many presents we have until we've parsed the next line. We can't peek ahead. We can't reverse the So we have to just read the whole thing in. It's not a big deal. Dimensions equals, yeah, make a new array of dimensions, and we'll make an array of presents. We'll have to figure out a way to store the present data. We need multi-dimensional arrays here. We really do. This sucks. Just storing this data is going to be tough. Listen, I'm glad you're invested, but we might not figure this out tonight. We'll see. I'm going to try my best, but it's already going to be tough just because of storing this data. There are ways we can store it, but, you know. So we'll just store what we can, and we'll go from there. If the line is the dimension regex, then... Oh, we don't even need to change the state, but we'll do it anyways. Because this is the last thing we'll encounter. Then dimensions plus equal, and we'll make a new string to represent this. And that will be the width is bash rematch 1. The height is bash rematch 2. And the things are bash rematch 3. So we will just do width, height, things. Yeah, we'll just do 2 read commands. Okay. And now if we are down here, we can check. Oh, let's just assume the input's valid. elif -z line, meaning it was unset, then continue. So now if we're down here, assume we are reading present data. Let's go ahead and push stuff into the line, into the present data. So we can say the presence at present index plus equal the line and a space character. It's ugly, but we got to get this data in somehow. So that might be a little bit confusing here. Let's go ahead and var dump the dimensions and just make sure we've written something that works. So we've read the dimensions in of the example, and we have 4, 4, 12 by 5, and 12 by 5. And there's no other data to the right of it. So I messed up something there. So the dimensions width, height, and things. Oh, because I didn't put a capture group here. There we go. So there's the width, the height, and the things. Okay. So now we got the dimensions. Let's go ahead and var dump the presence. This is going to be hideous. But, okay, so this is wrong. Oh, yeah, I see. There we go. Okay. So this might be a little bit confusing, but here's the dimensions. So a 4 by 4 has to have these things in it, and these index refer to this and the count of it. And this is one present, because here's the top part of the present, here's the middle part of the present, here's the bottom part of the present. Here's the top, the middle, the bottom. This sucks, but we don't have 2-dimensional arrays. So let's just get an idea. Okay. So the real input is brutal, but the real input is mostly solving puzzles. The presents are still 3 by 3s. So the presents really aren't that big of a deal, which is nice. So how do we do this? The first region is 4 by 4, and we just need 2 of those presents, and we know it does fit. So if we... Can we read everything but the bottom 2 of the file? Is that like a tail plus n? Is there like a head minus n minus 2? It's not a thing. Darn it. How do you chop off the last 2 lines of a text stream in Unix? I guess you can get the actual count of the file. 33. And then we can just head minus 31 it. There we go. Cool, so now we're just testing one present. Okay. Sometimes you can do header tail with a negative line count. Yeah, I thought so, and it wasn't working for me. I thought you could do like tail plus 2. Now, I am on Mac, so maybe that's not a thing. Maybe I have to do I have gtail on here? I do have gtail. Second byte of the input? What? I'm getting distracted here. Okay, no, we gotta lock in. We already have the head version that works. We have head minus 31. That is good enough. So we have to make a 4x4 grid, and we have to include 0, 1, 2, 3, 4. The puzzle, the present in index 4 needs to be included 2 times in a 4x4 grid. Index 4, 0, 1, 2, 3, 4 is right here. This present needs to be included twice in a 4x4 grid. We need to test to see if it's even possible. I don't even know how you do that, bro. I have ideas. They're not efficient, but I have ideas. Pick an anchor point for the president. Pick an anchor point for the present, maybe the top left of it. Whether it's a period or a pound sign doesn't matter. Overlap it with the map. If it's valid, then go from there and try the next one. We're depth first searching a brute force solution to this. Because all we have to do is get one that works. If it works, then that's a true or false. All we need is a Boolean out of this, whether we can or not. So yeah, we should do a depth first search first, because if we get lucky, if we hit one, then we can stop. So let's do this. 4 dimension in dimensions do echo testing dimension. Done. Now we can do this. We can get the data we want out of it. So read-r width, height, the rest out of dimension. And now we need to read into an array of to try, or the puzzles that we want to try, the pieces that we want to pick. The goal. It's an array of all of them. A little bit confusing, but we'll have we'll say echo testing width by height var dump the goal. So I'll show you guys what I'm talking about. So testing a 4x4, and here's the goal of what present should be included. So it's tough. And you can rotate them? Dude, come on. I guess the first thing to do, because there's no overlapping, we can, I don't know if we can throw up puzzle pieces real quick by counting the number of hash marks that we want and comparing it to the grid size of the puzzle. Eric usually isn't mean in that way, but it's still an easy way to just go through and do it. Because I imagine the puzzles that don't fit, like, they almost look like they could fit, but they just don't. So we could try doing something like that, but that just gets us, that eliminates stuff. We haven't even come up with a solution to solve this problem. But if I were to solve this problem, I would enumerate this index that many times. Now, can we rotate, or can we just flip them? Rotated and flipped as necessary. So that means we could flip it and then rotate it. Like, Okay. I don't know how else to do this besides like brute forcing it. So let's try that. Let's make a helper function to load a present into an array, into a thing. So this will take the index of a present as the first argument. It'll grab it from the array of presents that we have. And then we will loop over it and we will put it into the an associative array so we can index it nicely. I think all the presents are 3 by 3. Are they even the same size? Are they the same shapes? I think they're the same shapes too. No, they're not. But they're all 3 by 3. Let's cheat. They're all 3 by 3. We're not really cheating, but for y is equal to 0, y less than 3, y plus plus 2. Eric, if you're around, I'm very curious if you when you make these puzzles, do you expect certain puzzles to be difficult? Like, did you expect day 10 part 2 to be like as brutal as it was? We've got 2y plus plus there. Oh man, that would have been fun. You don't like x less than x too? That's a really good condition to test for. You expected it to be difficult? Okay, cool. That's good to know. Y equals 0, y less than 3, y plus plus, x equals 0, s less than 3, x plus plus. Okay. Now in order to this is just a giant string. So load it into an array. And now to get the character out of it, we have to get the array spot. The array spot at y and get the x character out of it. We are so doing so much extra work because we don't have nested arrays. Yo, that's a very good question about Linux and operating stuff, but I'm sorry, I can't give you an answer to it right now. I'm locked in. We're doing some puzzle solving right now. There we go. You can make one big array and then index into it cleverly. Yeah, there are ways to do that. I didn't click load present. Okay. Now we should figure out, here's the presence we want to test. The order in which we test the presidents, oh my God. The order in which we test the presents doesn't actually matter, I don't think. So we can just go through and start testing them. Let's see. To get into an operating system like Linux kernel, the first step, you have to make yourself very, very, very small. Otherwise you won't fit. There you go. That's some good advice. Yeah, this part 1 does seem very, very difficult, like compared to the other previous puzzles, but you are right there, but this is still fun. All right, 4 index in goal. No, I don't want to do it this way. I do want to do it this way. Want 0 to be in the puzzle 0 times. Want 4 to be in the puzzle 2 times. So we want this one to be in the puzzle 2 times. Cool. Want IDX to be in the puzzle amount times. Okay. I have too many var dumps in here. That's printing too many times. Want 0 to be in the puzzle 0 times? That's great. Why are we calling load present on it then? Oh. Yeah. Okay. So this is the piece that we want to be in the puzzle. So how do we do this? You know, I'm thinking about this where in my brain, I'm trying to solve it, like go through the puzzles one by one and then fit all the pieces into it. But there's only 6 pieces, 6 presents, and there's a ton of puzzles. So it might make sense to figure out different combinations. I think I'm redesigning puzzles in my head. It would be nice to know, like, oh, you want to put 3 of these pieces together? Well, they can only, like, the smallest we could do that is this. It may make sense to think about it that way. I don't know yet. I'm just spitballing ideas here. But it may make sense to have an idea like, oh, you want to make a 5x5 puzzle with these 3 pieces? Those 3 pieces will never fit in a 5x5 puzzle. Kind of like the, you know, a triangle, 2 sides must be in excess of the 3rd side. Like if someone said, hey, what about the triangle 2, 3, 9? I'd be like, well, that's not a valid triangle. Like I can throw it out without even having to draw anything. That might be useful. I don't know if it's useful yet, but that might be useful. Having to rotate and flip it is gnarly. Because I can visually look at this right here. I can look at this myself and see that, oh, flipping it doesn't do anything that rotating doesn't do. I can see that it's symmetrical. How can I make code see that? I don't have to, actually. Because if I go into let's do the example input, I could just go look at these and inspect them myself. Like if I rotate this one, this one will be different rotated than it will be flipped. Flipping this one will result in a different shape. Flipping this one will result in a different shape. Flipping this one will still resolve in a different shape. Yeah. Flipping this one won't make a difference. So I know that 3, we have less things to check. 4, less things to check. 5, less things to check. Okay. So the first 3 presents in the example input can be flipped. The last 3 don't benefit from being flipped. We could write code to test for that, rotate it in 4 directions, flip it, and see if there's just keep track of every unique way. Oh man, okay. Because for every puzzle piece, like this puzzle piece right here, let's pick this puzzle piece because it's symmetrical. This puzzle piece has only one other way. You can just rotate it 90 degrees. If we rotate it 180, nothing's happened. If we flip it, nothing's happened. In any direction, you flip it in any direction, nothing's happened. So if we dedupe a bunch of these things, there's only 2 possible states. So this present, even though there's, it seems like there should be 8 different ways, there's only really 2. There's only 2 ways this present could show up. When I look at this one, 1, 2, there's 4 different ways this can, because flipping it doesn't do anything, but rotating it makes a difference. This one, 4. This one, I think there's 8 here. Yeah, so some of these puzzles, some of these presents get out of hand really quickly. This is a tough one. Let's take a piano break. All right, piano break over. Let's write some code. I don't know how we're going to do this, boys. I'm going to be honest. This is a tough one. Because, there's the brute force solution, obviously. It's not ideal. Brute force, so true. Brute force solution gets out of hand very quick. Doesn't mean it can't be done. Doesn't even mean it's not efficient. It just means it's probably a cleaner way to think about this. I almost want to optimize the input and figure out ways they can be plugged into each other, but there's just so many. This is a cool problem. I like this one. This one's going to be the, I don't know, day 10 part 2 is going to be very tough. I think this one is going to be equally tough, but for a completely different reason. That's my hunch. I'm going to go ahead and steal some code from previous years to do a print grid. Because I don't feel like writing this again. Yeah, it's just a simple function to print a two-dimensional grid. Okay, now we have our print grid function. Let's go ahead and load map. Let's call it load grid. Let's call this grid. Let's just be consistent, huh? There we go. Now we don't need to hard code the X and the Y. Load grid. Width, height. There we go. So now we need a load grid function. It's not normally how I program, but I think we're onto something here. Let's go ahead and run this. Oh, I did the whole entire example. I need the had 31 of example. Okay. Oh, I loaded the grid. I didn't print it. Print grid. Beautiful. How did this not work? Oh, that's not how it's stored. Yeah, we need to do this. Using a bunch of global variables, I don't care. Okay, we're testing a 4x4 grid that looks like this, and we have to try these two pieces on it, so... This is a really tough one. Try to fit present. How's that for a function name, guys? Huh. Okay. I'm thinking. I don't like this solution. There's something better I can do here. I have to stare at this and wait for a divine intervention. It's funny, it's so similar to last year's day 25, like with the lock and key, but significantly harder. Significantly harder. Oh, Eric, do we have a bot on our hands? Is that what's going on? What's the problem now? Oh, man, it's too difficult to explain. Oh, man, I'm too far into it. But Advent of Code, day 12 for 2025 is what I'm working on right now. We're trying to fit these presents as compressed as possible. That's not true. That's not actually the problem. Trying to see if we can fit these presents into a grid size of an arbitrary size. This is tough, man. I guess we just brute force it and then we try to optimize it. I think we're going to have to, because trying to think of the way to fail early here. I mean, the way to, as long as we find one way that works, then we can leave. So it seems like depth first search is going to work. And I think we're just going to start putting things in the grid in that fashion. So like, well, I don't have the try to fit present. We have a grid of this size and we have a present. We are going to try and put I'm just trying to think of how slow this will be, but I should probably stop thinking ahead. We'll try to put the first piece here. The first piece will fit. If the first piece fits, Then we try to put the second piece. We loop through the entire grid. We take the top left piece of the puzzle, the present we're trying to put in there, and we plop it in. If we have an overlap, we try again, plop it in. Try to place it, rotate it, place it, rotate it, place it, rotate it, place it, flip it, rotate it, place it, flip it, rotate it, place it, flip it, rotate it. I think you get what I'm saying. That super duper sucks. It super duper sucks. It solves the problem, but I don't know if it's going to be very, very slow. Now, when I say I don't know, I mean I legitimately don't know. So we should actually probably try it. Yeah. So let's try this. Let's put it all in a function. This will give us like early returns and stuff like that. 4-dimension in this. We've read all this. Now we will put this into solve puzzle. So solve puzzle will take the width, the height, and the amounts. If solve puzzle, then total plus plus. Okay. Let's make a new array of things to try. To fit equals this. Okay. Okay, so to fit, we need to fit present 4 and present 4. So this is an array of the presents we have to fit in order. The order doesn't really matter. Maybe there's a way to optimize it. But now we're going to try and fit these. So 4 index in to fit do done. We will get the present out of it. So we will load present index. And then we will try and fit it in there. Where do we initialize the grid? Here we go. Let's initialize it to zeros. Okay. Now we can loop over this. Okay. And all the presents are 3, so that's very useful. For y equals 0, y less than grid. No, y less than height minus 3, y plus plus, for x equals 0, x less than width minus 3, x plus plus, do, done, Done. Okay. Okay. Now when we are down here, no rotating yet, no anything. We're going to try and fit the piece in. So the grid of yeah. Oh, this sucks. Okay. Changing these I so we can keep X and Y. So we know how much to augment the X and Y by. Okay. So now we have present grid that we can use. Let's get the character out of that. Present grid at character I, comma, J. Wait, are we looping over Y? No, we're looping over YX. So J, comma, I. Good. This is not confusing. And then we will, if C is equal to a hash mark, then the grid at the grid where, bro? We can't have this many for loops. Oh, wait, I see the problem is. Okay. Y equals 0. Y less than height, minus 3. Y plus plus. We're looping over the grid. Now that we're inside the grid, now we need to loop over the presents. So the presents are always 3. So for I equals 0, I less than 3, I plus plus. For j equals 0, j less than 3, j plus plus. Okay. Now that we have that, dude, you're not the only one who's lost, man. Don't worry. Now that we have that, we can grab the, this sucks. We can grab the present from the present grid, which is always going to be the i's and j's. That's fine. If the character is a hash mark, then the x and the y of the grid gets incremented. But we need to save the grid. Save grid and restore grid. There's got to be an easy way to just save a whole grid, right? I think you can do declare -p. I don't know. This is a nightmare. This I've never written this many nested for loops. This is wrong. I mean, it's not wrong, but like it sucks. All right. We are gonna need a bigger terminal. Is J minus 3 instead of J less than 3? Oh, the goat. Thank you. Thank you. Legend. I can't believe you're looking at this garbage code. The worst case is 160 trillion. Yeah, not great. No, I shouldn't put the check here. I need to check to see if the grid's invalid. Yes, that's correct. If C is greater than 1, then okay. Now I have a grid invalid function. That's great. I need to continue 4 here. Are you serious? I need more functions. And we save the grid. We put the pieces in there. And then we check at the bottom if the grid is invalid. Then we restore the grid. We try again. And if the piece fit, all right. I give up for now. My brain's a little bit fried right now. I don't think I can solve this now. I've been streaming for 4.5 hours. So we got day 11 done completely. We've made some progress on day 10, part 2. And we will have to put day 12 off for another day. It's just not going to happen tonight, dude. My brain's fried. I'm so tired. But we tried. I mean, you can hear my voice. I'm losing it. I gotta go lay down. Gotta fire it in there on some sleep. Oh, man. But yeah, so thank you everyone for watching. I appreciate it. I am enjoying these Advent of Code streams. They are a ton of fun. So I appreciate you all tuning in. Yep, if you're on Twitch, go ahead and hit that follow button. And if you don't follow me on YouTube, you should do that. I have a channel called You Suck at Programming. We're at like 60-something thousand subscribers. I'm doing pretty well over there. If you're on YouTube, what's up? I'm famous. But yeah, if you're interested in learning how to write Bash and Bash scripting, the Bash course that I'm working on will be completely free. It'll be on YouTube and it'll be out within the next 7 days. That's my promise. We'll see if I can actually live up to that. But yeah, definitely coming out this month. Fun times. Thank you, Eric. Yo, I appreciate you. I appreciate you making these puzzles. These are a ton of fun. This puzzle is crushing me right now. My brain's a little fried. I'm also having to do the Bash thing of trying to like put these pieces of data and data structures that are not built for it. So, I'm having a rough time here. This might be one of those puzzles where I solve in Rust and then backport to Bash, and even then, I don't think this brute force solution is going to work. I think there's going to be a way more clever solution. But we're having a great time. Thank you, Eric, for these awesome puzzles. I'll be back. We'll be streaming the solutions to day 10, part 2, and day 12, part 1, and so on. So yeah, congrats on the day 11 solve. Thank you. Yeah, I'm glad we crushed both of that. That was super nice, and it was just uplifting to get some stars. You know, I feel like I'm playing Super Mario 64. You just got to grab some stars where you can. Yeah. So yeah, look forward to the Bash course. I appreciate you all. Have a good night. I'll talk to you all later. This was a ton of fun. See you guys.